Hello guys, welcome back to my channel, Maison African Motives. Still working on O-level mathematics. In this platform, we are just going to focus on the question paper, which was written in June 2011, and that's the full paper that we are going to focus on. So we should just try to quickly rush through the questions. So make sure you've got these additional materials that you are needed to have: the answer paper, the geometrical instruments, graph papers, 3 sheets, mathematical tables. Here is actually a calculator for you, and the plain paper, which is 1 sheet. Okay, then remember your instructions, guys. I always say that it's very, very important that you work with the instructions that you're given. It's something that is very, very important. The information that you're given, in this case, we are given that from the instructions to candidates, mostly on all working must be clearly shown. It should be done on the same sheet as the rest of the question. Then omission of essential working will result in loss of marks. If the degree of accuracy is not specified in the question, and if the answer is not exact, the answer should be given to 3 significant figures. Answers in degrees, that is, you're dealing with angles, should be given to 1 decimal place. So whenever you are dealing with an angle, your answer should be to 1 decimal place. Okay, so that is the most important part, and make sure you read everything that you'll be given. So let us quickly rush through, guys, and see what we are given. Okay, so the first question is to simplify 3 and 1 over 2 minus 1 and 1 over whatever that you have, and this is a division that you're given. So these two, they're dividing. Okay, so I'm just going to simplify aside here. Okay, so if we are to cross check, we have to multiply whatever that you're given here, multiply, then we add. So if you multiply, we're going to get 3 by 2, which is 6. So this is going to be 6 plus 1, which is 7. So we're going to have 7 over 2. Minus, we do the same, we multiply, that's by 5, that's 5 plus 3, which is 8. So it's going to be 8 over 5, like this. So this is still in a bracket. Whatever that we get, we divide 2. If you multiply here and add, it's going to be 3 plus 2, which is 5. So this is 5 over 3. Okay, so from the information that we are given in this case, you remember your board mass. From your board mass, let us just write here our board mass. All right, so from our board mass, we have brackets of division and whatever, so we've got brackets first. So which means we are going to simplify the brackets. That is, from these brackets, we have to find the LCM of these two, 2 and 5, that's 2 by 5, which is 10, that's our lowest common multiple. So we have to subtract, so divide 10, divide by 2. So you're dividing this 10 and 2, which is 5. Then 5 times 7, that is 35. Minus, we divide again 10, divided by 5, that is 2. Then 2 by 8, which is 16. So whatever that we are going to get here, we have to divide to 5 over 3. Okay, so that is what you're going to have in this case. So now this is paper 2, guys. You can subtract this part from your calculator. 35. Let us just put aside, yes, 35 minus 16. So if we are to subtract these two, you're going to get 19. So this is 19 over 10. So that's 19 over 10 divided by 5 over 3. Remember, if you are dealing with division, you have to introduce multiplication here. So you're dividing, so you're supposed to multiply. So it's going to be 19 over 10 multiply by, but the moment that we introduce multiplication, remember what happens, we are going to invert the second fraction here. So we're going to invert, and this is going to be 3 over 5. So we're going to have 3 over 5 in this case. Okay, this is paper 2, guys. Do not worry about much, just use your calculator here. 19 over 10, like that. Okay, then we multiply to 3 over 5. So learn your calculator also to your advantage in paper 2. So this is 57 over 50. Okay, so that's 57 over 50 here, of which you can express as a mixed fraction. That's shift here, which is going to be 1 and 7 over 50. All right, so that's paper 2 for your advantage. It's going to be like that. So as you can see, guys, it's a matter of understanding the concept that you'll be given. Okay, so we move on to the item B. So we've got B item 1 here. Find the exact value of 10,03 times 0, so you simply have to multiply the 2 here, so you can just even write them here. All right, so this is B item 1. So we have got 10,03 multiply by 0.7. So this is paper 2, guys. Okay, let us just multiply just in sake for knowing also the advantages of multiplication if we can apply this. Okay, so if you have to multiply, remember from your multiplication, all we need the decimal places, that is our placeholder. So we've got 1, 2 here. So we've gone to actually we've got just one, because we are going to like ignore the commas here. So let us just ignore the commas so that we do not mistakenly multiply. So it's 10 comma. Okay, guys, I'm saying let us ignore the commas. Okay, so this is 0.3 multiply by 17. Okay, so if you have to multiply, that's 0 here, 1 as a placeholder, so just going to have 0, you put 1 this. So multiply by 1, so it's 1 by 3, which is 3, 1 by 0 here, which is 0, 1 times 0 again, which is 0, 1 times 1, which is 1. Then we are done. We move on to 7, 7 by 3, that is 21, give it 2 here. 7 times 0, that's a 0 plus 2, which is 2. 7 times this 0, that's a 0. 7 times 1, that's 1. That's 7. So you can add these 2, that's going to be 0. Guys, that's 1 here. 0 plus 1, that's 1. 3 plus 2, which is 5. 0 plus 0, that's a 0 here. We've got 7, we've got 1. Okay. Now, on our answer, now we're going to cross-check the number of decimal places. We've got 17051. Our main decimal place are going to have got 1, 2, 3, 4. That's 1, 2, 3, 4. So our answer is going to be 1,7051. So that's it. We can even cross-check paper 2, guys. This you cross-check also on your calculator. 10,03 like this times 0.17. You just cross-check your answer. You see that's the answer that you got. So that is the idea there. Okay, so let us see the other part. 7.2, this is divide by, that's a division there. So you're dividing 7.2 by 0.08. All right, so you're just going to have it here. So this is B item 2. So we are given 7.2, that is divided by 0.018. So in this case, I'm just going to write it as a fraction, like 7.2 over 0.018. So I've got 3 digits after the comma, actually 1, 2, 3. So which means I'm going to multiply by 1,000 here by 1,000. So by multiplying by 1,000, that means 7.2. I'm going to move 3 commas to the right because I've got 3 zeros. So that's 1, 2, 3. In place of these grooves here, in place of these grooves, you just put a 0 here. So that means we are going to obtain 7,200, which is 7,200. Okay, so this is 7,200. So we are going to have 7,200 over. Multiplying by 1,000 was for us to remove the number of decimal places, which is these ones. So which means it's going to be 18. All right, so from there you can divide, guys. This is paper 2. Do not waste time. From this part, 7,200 divide by 18 like this, you get 400. So this is equal to 400, just like that. Even if you cross-check, guys, the marks, you're not supposed to do this. Just use your calculator direct, because look, it's just 2 marks. So even with the working that we have, it's just 2 marks, which means it's just 1 mark here. So all right, anyways, 3 farmers shared 120 hectares of land. So we have got 3 farmers who shared the land in the ratio of 3:4:5. So this is the ratio of hectares like in sharing. Calculate the area of the largest piece of land. So if you have to cross-check according to our ratio, the largest ratio in this case is 5. So what you're going to do is from the 120 hectares that you're given, 120 hectares. So this is actually C. I'm just going to write it aside here. So this is C. So 120 is going to represent the total ratio, which is if you add 3 plus, okay, we can just even use a calculator. That's 3 plus 4 plus 5, which is going to give us 12 according to the ratio. So 12 is equal to the total number of hectares, which is 120 hectares. Okay, so if this 12 is going to represent 120 hectares, what about the largest piece of land, which is in this case, it has got 5. So according to ratio, it's 5. What are we going to get as the amount of land that you're going to have? So as you can see, 5 is less. So this is less here. So using the less concept, is going to be 5 over 12. Okay, that is the less value, 5 over 12 times 120. So like I said, guys, paper 2, take everything to your advantage. So 5 over 12, whatever that you get here, multiply to 120, we are going to obtain 50 hectares. So which means this one is going to have 50 hectares, the one that has the largest piece of land. Okay, so that was what we simply needed. D, find the highest common factor, which is the HCF of these expressions. So remember, for you to have the highest common factor, all you have to is write these numbers as product of their prime factors. Then from there, you can actually simplify. So this one, you can even do it here, guys, without wasting much time here. So 27 as a product of its prime factors, you can divide by 3. 3 into 27, that is 9. 3 into 9, that is 3. 3 into 3, that is 1. Okay, so it means this 27 can be written as 3 times 3 times 3, which is 3 to the exponent of 3 by x to the exponent of 2 by y by z. Okay, so that is what we have. Then 72, we can do the same here. 72 by 2, 2 into 72. That's 36, 2 into 36. So also your calculator is there. You can simply divide 72, divide by 2. You get your answer straight. You divide again by 2 because this is now 36. You get 18, something. So it can be easier like that, guys. So 18, 2 into 18, that's 9. 3 into 9, that's 3. 3 into 3, that's 1. Okay, so which means we've got 2 times 2 times 2, which is 2 to the power of 3. So this is going to give us 2 to the power of 3 times 3 times 3 here. We've got 3 times 3, which is 3 to the power of 2. So that's 3 to the power of 2 times x times y to the power of 3 times z to the power of 2. All right, so we've got 108. We move on to 108. We do the same. 108 by 2 here. That's 2 into 10, that's 5. 2 into 8, which is 4. 2 into 54, that's 2 into 5, which is 2, remainder 1, which is 7 into 14. As you can see, we have to move on to 3. 3 into 27, that is 9. 3 into 3, that is 3. 3 into 27, into 9, that is 3. 3 into 3, that is 1. So you've got 2 times 2, representing 108. So it's 2 to the power of 2 by 3 times 3 times 3. So you're multiplying 3 times 3, 3 times. So it's going to be 3 to the power of 3. Whatever that we get, you multiply to x times y times z to the power of 3. Okay, so you have written your numbers as a product of their prime factors. Okay, so now the HCF, remember guys what I told you, that the HCF has to be common throughout. It's a term that is going to be common throughout. So as you can see, 2, but here we do not have 2. So 2 is not common, we are not going to take it. We move on to 3, we've got 3 here, we've got 3 here, we've got 3, okay? If it is common like this, we are going to take the one with the smallest or the lowest power, the smallest power. All right, so which one is got the smallest power? That is your highest common factor now. So it's 2 to the power of 1, it's 3 to the power of 2 here, because this is 3 to the power of 3 to the power of 3. This one is got the smallest power, which is 3 to the power of 2. You move on to x is common. Is x common? We've got x here, we've got x here, we've got x here. X truly is common, so this is going to be x. You move on to y, is y common? We've got y here, we've got y here. Yes, y is common. You move on to z, z is common, we've got z. So you take the one with the smallest power, y is the smallest power, z is the smallest power. So this is your highest common factor. Okay, let's say the question needed us to calculate the LCM. What were we going to do? Okay, in this case, this information, we no longer need it. Let me just erase everything here. Let's say the question needed us to calculate the LCM. What were we going to do? Okay, the LCM this time, you take everything. It's not about being common. As long as the term is present, you have to take that term. Okay, anyways, guys, we're supposed to simplify. I wonder, someone will be wondering what is happening here. 3 to the power of 2 is what? Is 9. So this is 9xyz. Okay, it's just in case you have to simplify further. Okay, so I was saying here for the LCM, it's not about the term being there like common. It's about a term just being represented. As long as the number is there, or the term, which is the letter, is there, you have to take everything. But when the terms are repeating, like or the terms are common, like we've got a term and a term, you take the one that has got the the highest exponent this time. So this is LCM. So you take the one with the highest power. Okay, so it's not about being common, is about being there, present, being present, and you take the one with the highest power. So we've got 2. 2 is present, as you can see, there's 2. So you're going to take the one with the highest power, which is 2 to the power of 3. So that's 2 to the power of 3 times. We've got 3. Which one has got the highest power? 3 to the power of 3, 3 to the power of 3. So this one, you just write 1, 3 to the power of 3. You move on to x. Which one has got the highest power? That's x squared. So it's times x squared. You move on to y. Which one has got the highest power? That's y to the power of 3. You move on to z. Which one has got the highest power? That's z to the power of 3. Okay, so you can simplify 2 to the power of 3, that is 8, times 3 to the power of 3, which is 27, times x squared times y squared times z to the power of 3. So you can multiply 8 times 27, that's 8 here times 27, that will be 216. So this will be 216 x squared y squared z to the power of 3. So this is to the power of 3 here. So that is the idea. Y, we've got y, we said y to the power of 3. Sorry, it's now the marker which is showing this y to the power of 3 there. Okay, so that will be your LCM. So LCM is the one that will be having the highest power. So I think it's clear from this part. Okay, let's see number 2. On number 2, it is given that R is equal to 2Q minus 5, and Q is equivalent to 3P plus 2. Express R in terms of what? In terms of P. All right, so if you have to cross-check the expression that we are given here, it's of R in terms of Q, not in terms of P. So for us to have R in terms of P, we are supposed to substitute Q, because Q is the one that carries P here. So it means in place of Q here, you are going to substitute with Q, which is equal to 3P plus 2. That is what they are trying to say in terms of, which means your answer must have P. So which means our R in this case is going to be 2 times, that is 2Q means 2 times. So you open a bracket. Since this is an expression, you have to multiply everything. So it's going to be 3P plus 2. Whatever that we get, we have to subtract 5. So there's a minus 5 there. So let us multiply 2 by 3, that's 6P. 2 by 2, that is 4 minus 5. You can collect like terms. That's 4 minus 5, which is minus 1. So this is R in terms of P, okay? So that was your item 1. Then the item 2 now is for us to find the numerical value. So numerical value, they're now saying the number, it's a number, not an expression. This is an expression, this one. But the numerical, you have to find the equivalent number now when P is equal to minus 1. So what am I going to simply do? I'm going to substitute direct here because we've got R in terms of P. So R is equal to 2 times P. Our P is minus 3. So it's minus 3 like this, plus that's a minus 1. So whatever that I get here, I have to subtract 1. Okay, so let's multiply 2 times minus 3. That's minus 6 minus 1, which is going to be minus 6 minus 1. That's minus 7. All right, so we are going to obtain a negative 7 if we cross-check properly here. Okay, that's a negative 7. So that is the value of R that we are going to have from this part. It was negative. This is, all right, let us cross-check, guys, our part. This is 6P, not 2. All right, so here I'm supposed to take this. I hope someone saw this, guys. Okay, so let us correct this part. Okay, let's correct this part, guys. We are saying that our R here is equal to, okay, so let's just correct this. It's 6P minus 1. Okay, so that's 6 times P, which is our P is minus 3. So guys, sorry for that. All right, so this is going to be negative 18, negative 1, which is negative 19. Okay, yeah, can make sense now. So that's what you're going to have. Then the item 2 express this as a single fraction in its lowest terms. Okay, so as a single fraction, let us just work it aside here. All right, so we're given the expression that is in this case. Okay, let me just change. Okay, this one can look better. So we're given the expression of item, this was item B, item 1 actually. So this is B, item 1. So we're given the expression of x over 3 plus x minus 4 over 5. So you're asked to express this as a single fraction in its lowest terms. Okay, so how am I going to have this as a single fraction? That is the question. So in order for us to have a single fraction, this is what we're going to find the LCM of this. So because we want to add the two. So what is the LCM of 5? Oh, sorry, I just need to change here. So what is the LCM of 5 and 3? That is 15. Okay, so from this part, remember the concept, divide your LCM, divide by these 3. So it's 15 divided by 3, which is 5. So whatever that we get, we multiply to x. So 5 times the numerator, that is 5x, plus 15 divided by 5, that is 3. Whatever that we get, we multiply to x minus 4, which is our numerator. Okay, so from this part, we are going to have 5x plus 3 times x here, which is going to give us 3x, 3 times minus 4, which is minus 12. Okay, so that's what you're going to have, everything over 15. So from this part, we can collect like terms. That's 5 plus 8 plus 3, which is 8x minus 12 over 15, like this. Okay, so that's what you're going to have. As you can see, if you factor out 4, which is common, it cannot divide with this 15. So just leave your answer like that. So this is what you're going to have as a single fraction. So that was the concept here. All right, now if we have to cross-check on the other part now, it's hence or otherwise. It's now an equation that you're supposed to solve. Okay, hence or otherwise. So hence it's a continuation from what you got here, continue from there. But otherwise, you can use any other concept. So you ask to solve this equation. So as you can see, this part here is the one that we have expressed as a single fraction. So we are going to equate to 4. So already here we've got a single fraction that is your hence from this part here. Okay, so this is our item 2. Let us just have our item 2 here. All right, so this is our B item 2. So this is what we're going to happen. You are saying this expression that you've got 8x minus 12 over 15, that is hence. You continue from it. You equate now to 4 because we are told that this is equal to what? This is equal to 4, which means now you're now having an equation. All right, so let us cross-check if truly that is what we have here. So we've got a 4 over 1. Okay, so what am I going to do? Cross multiply definitely to remove the x here. So I have to cross multiply. That's 1 times 8x, which is 8x minus 12. Then 15 times 4, that's 60, or you can cross check from your calculator, 15 by 4. Okay, so that's 15 by 4 here, which is 16. So you're going to obtain 16. All right, so collect like terms, you can transpose the negative 12 to the other side of the equation, which is going to be negative 16, a positive 12. So it's 8x, that's 60 plus 12, which is 8x is equivalent to 72 if we add properly. So divide by 8, as we can obtain the value of x. So in this case, our x is going to be, you can divide 72, that's 72. Divide by 8, which is going to give us 9. So that's our x, which is equal to 9. So that was the condition. So guys, like I was saying, this is paper 2. Sometimes utilize the advantage of your calculator. So it saves you time in exam because it's all about time also. You have to utilize the time that you'll be given. Okay, so that was the hence method here. What about the otherwise method? Otherwise, that means you can expand by clearing fractions. Okay, so I'm just going to do the otherwise method here. Okay, so the otherwise method, you're going to take the fraction that we had, x over 3. So this was item 2. So it's x over 3 plus, let me just adjust a little bit here. So it's plus x minus 4. All right, over 5 is equal to 4. So that is the otherwise method now. So that is otherwise. So I don't know which way are you going to do, but as for the part of clearing fractions, I think that was the one that you're going to work, because now it's like you never worked with a question like this. It's like a new question to you. So you can clear fractions, remember, by finding the LCM of 3 and 5 and 1 here, which is 15. So you can multiply here by 15. Multiply here by 15, multiply here by 15. Okay, so that's it. If we multiply 3 into 15, which is 5 times x, that's 5x. We can divide again 5 into 15 here, that's 3. So it's going to be plus 3 into the bracket of x minus 4. This is an expression. So this 3 is going to multiply everything here, which is equal to 1 into 15, that's 15. 15 times 4, that was 60. Remember, we multiplied this before. So expand brackets. So how are we going to expand brackets? In this case, we are going to multiply by the term which is outside of the bracket, which is 3. So it's going to be 5x, 3 times x, which is 3x, 3 times minus 4, which is minus 12, is equal to 16. Okay, so that's it. Let us collect our terms together. We are going to have 5 plus 3, which is 8x, is equal to 60 plus 12. If we are to transpose the minus 12 to the other side of the equation, that will be a positive. So that's 8x is equal to 72. So as you can see, we are now back to the same part that we did before, where we got our x being a 9. So that is the case. So as you can see, guys, it's a matter of your choice. In this case, what you're given, you can work from there, depending with what is best for you. All right, so it was a matter of your choice. Okay, the B part, the C part is express 150 grams as a percentage of 3 kgs. So take note about the question, guys. We are told to express 150 grams as a percentage of 3 kgs. So percentage, you take what you're given. So this is C. So it's 150 grams as a percentage of 3 kgs. So it's over 3 kgs times 100%. So percentage multiplied by 100%. But in this case, you're supposed to note that here, because of the units, you can see that the units are not the same. This is grams, this is kg. So you're supposed to use the same unit. So in a kg, we know that in a kg, we have got what? We have got 1000 grams. So which means 3 kgs, we're going to multiply by 1000, which is going to give us 3000 grams. So it will be 150 grams over 3000 grams multiplied by 100%. So the gram and the gram can cancel each other here. So that's it. Paper 2, guys, with our calculator. So we're going to insert our calculator 150 over 3000 over 3000 like this, multiplied by what? By 100. That is the advantage of paper 2. So that's 5%. So this is going to give us 5%. All right, so that's what you're going to get in this part. So as you can see, guys, it's a matter of you and your calculator. Also, you are supposed to learn and how to apply or how to use your calculator properly. Okay, so that is what we had from this part. So as you can see, guys, that was our question. Question 2. So we just have to make as much questions as we can. Number 3, we are given a question which is now in psychogeometry. So in this type of a question, guys, what we are going to do, I want to do another part of answering this question of just filling in everything that we just know about our theorems. Since it's now time for revision, that's what you're going to do in this case. Okay, so here we're given a diagram shows points A, B, C, and D on the circumference of a circle such that BC is equal to CD. So this is BC equal to CD. So from there, let us start. Okay. A, B, C, D are points which are on the circumference, which means A, B, C, D is a cyclic quad. So you know that opposite angles, they add up to 180 degrees. Also, we know that the exterior angle of a cyclic quad, this exterior angle is equal to this opposite interior. Okay, let me indicate. Okay, so is equal to the opposite interior angle, which is this whole of this angle here, should give us what? Should give us 87 degrees. So by just saving this, okay, then we are given that B, C, and CD, these two are equal, which is this chord and this chord. So you know that equal chords subtend equal angles at the circumference. So you hold the chord B to the circumference, this chord BC to the circumference. We are going to create an angle at A, and from CD, we are going to create an angle at B. So I'm saying that these angles, they are equal. This angle at A and this angle, they are equal because they are subtended by equal chords. Okay. So also we are given it's 33. This is 33 degrees and 87. Okay. So from 33, what can we do? Like I said, guys, this time I just want us to fill everything that we know about this. Okay. So here we've got 33. Remember what a chord does. A chord here, AD, is the one that is subtending the angle at what? At C. So angles that are being subtended by the same chord at the circumference, and they're equal. So which means from AD, the angle that we are going to create at B here is going to be 33. So at B, we are going to have 33 degrees, which is this B here, which is ABD. But remember, before we said 87 here is the same as this one, which is 87. So we can find the remaining angle on B by subtracting 33 degrees from what? From 87. Okay, so that's 87 minus 33, which is going to give us 54. So that's 54 degrees. So this angle is 54 degrees. Okay. Also, if you have to cross-check from our code here, I want us to see what is happening. The code CD, this code C to D, is creating angle at B. Also is creating angle at A. So which means the 54 degrees that we are having here at B is the same as the 54 degrees that we are going to have at A. But previously, I told you that these two angles are equal from what? From this concept of equal chords, which subtend equal angles. So it means also this is 54 degrees. Okay, so like I said, guys, this time we just want to feel using everything that we know about the triangles that we have. So it means from there, we can even calculate the whole of the angle at D, this one, by just using angles on a straight line. So it can be 180 from 180 degrees, 87 from 180, sorry. So it's 180 minus 87 like this, which is 93. So it means this whole of this angle at D, the other part of D is 93 degrees. Okay, so that's what we can have. And also you can find this one, or you can even find this angle. Yes, you can find this angle at C here. Let us just fill and see. Okay, so this angle at C that I'm indicating here at C, which is ACB, since we've got angles in a triangle, we can simply subtract from 180 degrees all these angles that we have. So we're going to subtract from 180. So it's 180 minus these angles. Remember, 54 and 33 are the ones which give us 87. So it's just 87 plus what? Plus this 54. Okay, so if we subtract this from 180, we're going to obtain 39. So this angle here is 39 degrees, which is the same as this angle here because they are subtended by the same chord AB. AB subtends angle C, which means this angle at D is also 39. But remember, before we said the whole of this angle is 93. So 93 minus 39, we are going to find this remaining angle here. So that's 93 minus 39, which is going to give us 54. All right, so this is 54 degrees here. All right, we could have also taken from this one from chord BC. Since chord BC subtends angle here at A, it also subtends angle at D. So still these they can agree the same thing. So that's what we could have. We find this one at F. We find, so here I was just trying to show you guys that what is circle geometry. It's not like that is what you're supposed to do, but just know your circle. Okay, so anyways, let us answer our questions here. So our A, B, D, that's A, B, D. Okay, so we need A, B, D. A, B to D is what? 33 degrees. So this one we already have here. We already have it. So this is 33 degrees. Okay, CBD, CBD, that is from C here to B back to D here. We said it's 54 degrees. So just have to write our answer here. That's 54 degrees. We move on to BAC. So BAC, BA to C, we said 54 again. So this is 54 degrees. All right, we move on to another one, which is ADB. Okay, so this is ADB. AD to B, take note from A to D to B, that's 39. So that one is 39 degrees. All right, then CFD, so we've got CFD, which is this one, from C to F to D, which is this one that we didn't calculate. Let's see, it's needed. So CFD is going to be 180 degrees minus these angles, which is because we've got a triangle, so we're going to subtract 33 degrees plus 54 degrees. Okay, so using your calculator, just use it direct. 180 minus open bracket, that's 33 plus 54 degrees like this, which is going to give us 93. So we're going to have 93 degrees. Okay, so that was the answer for this one, which is 93 degrees. So that's what we needed, guys, to obtain a total of 6 marks from this circle geometry. So it's very, very important, guys, very, very important that you actually understand the idea of the questions that you'll be given, because that's how actually they can ask these questions. So you need to understand the concept of the question and how to answer the question is very, very important. Okay, so the B part, okay, it was actually a continuation. You're given a sector and you're asked to calculate PT. Okay, so this is a sector with an angle for 37. So as you can cross-check PT, you just have to use the right angle triangle concept, because this is 90 degrees. So according to 37, PT is opposite, and 8 here is opposite to 90 degrees. So which means this is your hypotenuse. So which ratio are we going to use, which has got opposite and hypotenuse at the same time? From your soccer tower, some they use Chashot tower, whatever that you have. So we've got soccer tower here. So we need a ratio which has got opposite and hypotenuse at the same time. So that is sine. So we know that sine theta is equivalent to the opposite over the hypotenuse. That is sine of the theta. In this case, your theta is 37 degrees, is equal to the opposite, which is the one that you want to calculate, that is PT. So that's PT over the hypotenuse, which is 8. All right, so this is over 1. You can cross multiply and simplify further. So here, what are you going to get? 1 times PT, that's PT is equal to your cross multiplying, then 8 times sine 39 is 8 sine 37, sorry, that's sine 37. So you're going to have PT as 8 sine 37, of which you can use our calculator. 8 sine 37, remember our calculator is there, so it's 8 sine 37 degrees, which is going to give us 4,81, something like that. Okay, so this is 4,81. 4, 5, something up to the last digit. So remember the degree of accuracy from what we read on our instruction. You're supposed to write this to 3 significant figures. So PT, okay, I forgot to put the marker here. Okay, so this is PT, which is equal to, we have got to count 1, 2, 3. So 4 is less than 5, it cannot change this one. So it's just going to be 4,81. And the units of measurement, we are given the units here in centimeters, 8 centimeters. So this is going to be also in centimeters. Okay, so that's your PT. Okay, so let's see the other part, area of the sector on item 2. So the area of the sector, this is your whole sector. So remember your area is given by the area of a sector is given by theta over 360 degrees by pi r squared. That is the area of a sector. Okay, from the area of a circle, you multiply by theta over 360. That is the idea there. Okay, so the theta is the angle that you are given, which is 37. So that's 37 degrees over 360 times pi. Use the given pi. The pi that you are given, take pi to be 3,142. That is the pi that you're going to use. Okay, so this is 3,142 times r squared, which is the radius. So the radius here is 8, which is this one that you are given. That's your radius, which means it's the same thing also from here. That is also 8 centimeters. Okay, so that is the radius. So we're going to multiply by 8 squared. Okay, so this is 8 squared. So like I said, guys, do not waste much time. You are in paper 2. So 37 over 360. Whatever I get, I multiply to 3,142. Whatever I multiply to 8 squared. Okay, so this is what I'm going to get. 20,6, something like that, 667 like that. So it's going to be 20,6. 6, 7, 3, 7, and so on and so on. So to 3 significant figures, that's 20, comma, we count 1, 2, 3. 6 is going to change this into 7, and this is area. Remember, area is measured in what? In square centimeters. Okay, so that's what you simply needed on item 2. Okay, item 3, the area of triangle PQO. Okay, so we need the area of triangle PQO, and if you are to cross check here, this is our PQO, this triangle here, and it's a non-right angle triangle. So actually, you can use the concept of a non, or you can use half base of this one times the height, but we can actually use this angle of 37 degrees, okay? Since we know that area of a triangle, if it is a non-right angle triangle, is given by half AB sine theta. So that is your item 3. So area of a non-right angle triangle is half AB sine of theta or sine C. So that is half of A and B. Those are the sides which are creating our triangle, which is 8 and 8, our angle. So that's 8 and 8, which is the radius and another radius. So it's 8 by 8 times sine theta, which is the angle which is in between. Remember, our angle was 37 degrees. Okay, so that's it. Here we can just maybe simplify this 2 into 8, that is 4. And you can multiply 4 by what? 4 by 8, which is 32, sine 37 degrees. All right. So from this part on your calculator, you have to simplify. That's 32 sine 37 degrees. Okay, so that's it. You're going to have something like 19,2. Okay, so that's 19,2 58, something like up to the last digit. So round off to 3SF, that's 19,3 square centimeters. Okay, so that's your area, because this 5 is going to change 2 into 3. So you're going to have 19,3 square centimeters. Okay, then the other part now, which is actually the last part of this question, question 3, is to calculate the area of the shaded segment. So the area of the shaded segment, this is a shaded segment, this one, where we are going to remove the triangle from the sector. So you're going to simply subtract the area of a sector minus area of a triangle. So area of a sector is there, area of a triangle is there. So you're going to simply subtract those two. Okay, so remember, this was our area of a sector, the one that we calculated. We calculated the area of a sector. Here we got 20,7. So we're going to subtract these two, 20,7 square centimeters minus the area of a triangle, which we calculated here, and we got 19,3. So we're going to subtract 19,3. So by doing this, if we are to subtract, we're going to obtain 1,4 square centimeters. That is the area of the shaded segment or the shaded region that we're given. So guys, make sure that you understand the concept that you're given. It can actually help when answering these questions. I think it's very, very important. So now let's cross-check the 4A item 1. That is to factorize completely. So they were given factorize completely. So guys, as we know that if you're dealing with factorization, if you're given 4 terms like this one, if we are to check here, we've got 4 terms. That's 1, 2, 3, 4. So we are going to group this into 2. So this is 3NP minus 6NQ. Plus AP minus 2AQ. So this is a 2AQ, like this. Okay, so remember that when you are dealing with this type of equation, you can actually group into 2, provided that we have got something that is common. So here into 2. Why? Because you can see that N is common here, so you can factor out N. But between 3 and 6, also 3 is common, so you can factor 3N. That is the highest common factor. Then if we are to divide 3NP, divide by 3N here, that's 3NP and 3N here. 3N and 3N will cancel, so which means you're going to remain with P minus 6 divided by 3, which is 2N, and N will cancel, which means you're going to remain with Q. All right, plus here, so that we are going to have the same bracket, so it's going to be plus A. AP and A, if you divide the A and the A will cancel, which means you remain with P minus 2AQ, the A and the A will cancel, which means you're going to remain with 2Q. Okay, so the brackets are the same here. So I'm just going to take out, factor out the common bracket, which is P minus 2Q, and I'll be left with 3N plus A. So in another bracket, I'm going to write 3N plus A. So that was the concept. All right, so let us move on to the other part. 12 minus 4G minus G squared. Okay, so this is 12. Let us have it here. So we are given here 12 minus 4G minus G squared. Okay, so in order for us to factorize here this time, we can see that the coefficient of G squared here is not 1, it's a negative. So which means we have to apply the longer way of factorization. We have to multiply the first term and the last term. So I'm just going to take this part here, multiply the first term to the last term, that is G and minus G squared, which is going minus 12 here, 12 here, and minus G squared, which is negative 12 g squared. So now we are going to find factors of negative 12g squared, but these factors, if you add them, they must give you this middle term, which is minus 4g. So which terms are we talking about here? Negative 6g and 2g. If you are to multiply negative 6 and 2, you're going to get negative 12. If you add these two, you're going to get negative 4. So these are the terms that you're going to replace into the middle term, which is minus 4g. So the question is going to be 12. In place of minus 4g, you replace these two terms, which is negative 6g plus 2g, okay, minus g squared. All right, so from this part, I'll be able to factorize. As you can see, we're now having 4 terms, and now back to that condition that we had before of having 4 terms. We are going to group into 2. So from this part, we can see that 6 is common, so you can factor out 6. 12 divided by 6, that's 2. Minus 6 and 6 will cancel, which means you're going to remain with negative g. Here we're going. You need to have the same answer just like what we had here. So we're going to factor out plus g, so that 2g and g will cancel. G and g will cancel. We remain with 2. Minus g squared and g will cancel. We remain with g. So as you can see, the two brackets here are the same. So that's 2 minus g into 6 plus g. So that is what you're going to have in this case. Okay, so I think it was simpler this way. On number B, we are given a survey of 72 girls. In a survey of 72 girls, it was found that every girl watched at least one of the following TV programs. So take note here, it's at least, which means all of them, they had to watch one. There's no condition of finding someone who is not watching any of the TV programs. So because there's at least, so at least means you're watching one of the TV programs. So the question now is that the teen scene, that is, these are the TV program, the teen scene and the fashion show. 50 watched the teen scene, 62 watched the fashion show. Find the number of girls watched both programs. So this we can use actually the idea of sets here. Remember from your sets, both those are the ones which are on the intersection. So since we are given at least, it means if you are to represent on your Venn diagram here, you are going to have 2 sets, okay, without that rectangle, because there's at least, which means we do not have a condition of finding anyone outside of these 2 sets, which is the teen scene and the fashion show. So we have got teen scene and fashion show. So that's what you're going to have. So take note, guys, in the teen scene, the whole of them, there are 50 girls in teen scene. So in teen scene here, there are 50 girls who are there, and 62 girls watched fashion show. So in fashion show here, we have got 62 girls. Okay. So from this information, we're going to ask ourselves to say, what about those who are watching both programs? So we are going to say, let them be equal to x. So that means in between these two, we are going to have x. But since in teen scene, we've got 50 of them, we are going to remove those who are watching both programs, so that we are going to remain with those who watch teen scene only, which is 50 minus x. So this is teen scene only. The same with fashion show. We want to find those who are watching fashion show only. So it's going to be 62 minus x. So from this information, we can now utilize this advantage to say there are 72 girls. So that means the total of everything here is equal to 72. So you can solve equating 50 minus x plus 62 minus x. Then you can equate now to the total number of girls who are in the survey, which is 72 girls. So equate to 72. So as you can see, we formulated an equation that we can actually use to solve for x, which is representing those who are watching both programs. Okay, so you can add 50 plus 62, that's 112. Minus x plus x here, that's a 0. So you're going to be left with minus x. So minus x is equal to 72. So since we want to calculate x, we are going to transpose negative x. We transpose the 112 to the other side of the equation. So it's going to be negative 112. So that is 72 minus 112, which is minus 40. So you're going to obtain negative 40 here. So this is going to be equal to negative 40. So to find x, divide by negative 1, divide by negative 1 both sides. So x is equivalent to what? X is equivalent to 40. So that was our x, which is those who are watching both programs. So those who are watching both programs is 40. Okay, that means here, if we are to take properly, you're going to see those who are watching both programs, that is x here. So it means we have got 40 on this part here, and this is 62 minus 40. We are going to subtract, which is going to be something like 22. Okay, and here is going to be 50 minus 40, which is 10. So that is what it simply means. So if we add this, we are going to obtain 72. That is what it actually means. Okay, so the question was to calculate those who are watching fashion show only. So remember, this is your fashion show only, those who are watching fashion show only. That is this part here that you are having, which is 22. So we got this one from 62 minus x. Okay, so this is our item 2. So you got this from 62 minus x. Where's 62 minus x? X, we got that our x is 40, and this ended up giving us 22. So these are the ones who are watching fashion show only. They are not watching Teen Scene or any other program. It's just fashion show only. So that is how you simply find this. You remove those who are watching both, because we said there are those who are watching both programs. So from the ones who are watching both programs, which is these ones that we've determined, which is x, you remove those, then you can remain with fashion show only. So that was the idea of the question. Okay, number 5, we're given convert 112 base 3 to a number in base 5. So remember, to convert in base 5, we can there are so many ways, but we can just simply convert this to base 10 first. 112 base 3 to base 10. We're going to raise to the power, or which is base of 3, 3 to the power of 0 to the power of 1 to the power of 2. So that means we are going to multiply 1 times 3 to the power of 2 plus 1 times, so here we are simply converting 1 times 3 to the power of 1 plus 2 times 3 to the power of 0. Okay, 3 to the power of 2, that is 9. 9 times 1, which is 9, plus 3 to the power of 1, that is 3 plus 1, which is 3. Any number to the power of 0, that's 1. So it's going to be 1 times 2, which is 2. So you can add, that's 12 plus 2, which is 14. And this number is actually in base of 10 now. So to convert this to base 5, because our answer is needed in base 5 here, what are you going to do? We are going to divide now by the base. Since we are now in base 10, so we are going to divide by the base throughout, which is 5 into 14, noting all the remainders down. So that's what you're going to do. So 5 into 14, that is 2 into 10. We've got a remainder of 4. 5 into 2 is impossible, so that's a 0 here, remainder 2. So our answer, remember, is taken from the bottom going up. So it's 2, 4 in base of 5. Okay, so that was the idea for this question, to convert from base 3 to base 5. Okay, evaluate the following, give your answer in base 2. So these ones, we can simply add them even here. Let us just add these ones here, guys. So it's 1, 1, 0, 1 base 2. Plus 1, 0, 1, 1 base 2. Remember, when you're adding number bases, the number is not supposed to be equal or to be greater than the base. So if we add 1 plus 1, that's 2, which is equal to the base. So what do we do? Divide by 2, noting the remainder. Okay, so that is what you're going to have in this case. Right, I need this part here. Okay, somewhere here. So like I said, if we have to add this, we are going to get 2. So we divide by 2, which is 1, remainder 0. So the remainder is the one that you're going to write on your answer in base of 2. Then this one here, we carry it to the next term. So it's 1 plus 0 plus 1, which is 2. So you repeat the same thing, which is 1, remainder 0. So it's a remainder of 0 here. You give a 1 here, 1 plus 1, which is 2. You do the same thing. Your remainder, which is 0, you give a 1 here. So 1 plus 1 plus 1, which is 3. So 3 over 2, that is 1, remainder 1. So the remainder on your answer, then this one, you're going to give it to the next term of which we do not have anything. So it's just like 1 plus 0, which is what? Which is 1. So 1 we are simply writing because it's under base of 2. You cannot write anything that is in base of 2 or above that base of 2. So that is the condition for the question. All right, number B item 1, show that 2 log whatever that we have is going to reduce to this quadratic expression. So whenever you're dealing with logarithms, okay, this is B item 1. So whenever we are dealing with logarithms, it's all about the laws that you're going to apply, which is the laws of logarithm. So you're given the logarithm, sorry, it was 2 log. So this is 2 log, all right. So this is 2 log of 3x plus 2 minus the logarithm of 2 in base of 3. So this is base of 3, which is equal to 1. Okay, so remember, guys, your laws are here. We're going to apply the law of P log M, which you know that P log M is going to log M to the power of P. We're going to raise the power to be, the base, the number that is multiplying the log to be the power of the logarithm. That means we can rewrite this as the logarithm of 3x plus 2 to the power of 2 in base 3 minus log 2 in base of 3, which is equal to 1. So the major issue is for us to have the bases which are the same, and we have those bases which are the same, which is base of 3. So we know that if we are in the same base, subtracting the numbers like the logarithms like this, we are going to divide the numbers. So whenever you're subtracting logarithms, you divide the numbers, provided that the bases are the same. So you're going to divide 3x plus 2 squared over the number that we have here, which is 2 in base of 3, which is equal to 1. Why are we so much worried about having our answer as a single log like that? Because we know that from a single logarithm, we can apply this law. The logarithm of A in base of B, which is equal to C, can be written as A is equal to B to the power of C, which is B to the exponent of C. So in this case, our A is this part here, the whole of this part, that is your A. Your B is the base, which is 3, your C is the power. So which means we are saying from this concept of changing from log to index form, it is going to be A, which is our A. In this case, we said this is everything, which is 3x plus 2 squared over 4. Okay, which is equal to the base B to the power of C, and our C is 1. So base is 3 to the power of 1. So it's 3 to the power of 1. So from there, we can actually solve. It's now just a normal equation, just like this is just a normal equation. Guys, let us cross check. Is this 3 or it's 5? Which base actually are we given here? So this is base of 5. Okay, guys, it's here now. My eyes are becoming affected by this. Okay, this is 5 here. All right, this is just 5. So which means this will be 5 to the power of 1. Okay, so from there we can now solve, because as you can see, we no longer have a logarithm. We're just left with normal equations that we can actually solve, because this can be over 1 like this. So you can cross multiply. That is this part multiplied by 1, this part multiplied by 4. So that means if we are to multiply by 1 and 1 times any number, it remains as it is. So this is going to remain as it is, which is 3x plus 2 squared, which is equal to, this is, remember, 5 to the power of 1, which is 5. So 5 times 4, which is 20. Okay, so that's our equation that we are going to, it's actually 2 here. This is a 2, guys. So it's actually 2 times 5 here, which is a 10. So that's a 10. Okay, so we can expand brackets and collect like terms. After that, we can we can actually show that equation. So if we are to expand brackets here, remember how you expand your brackets. We are going to have 2 brackets of 3x plus 2 into 3x plus 2, which is equal to 10. So multiply here 3x squared and 3x and 3x, that is 9x squared, 3x and 2, that is 6x, 2 and 3, which is 6x, 2 by 2, which is 4. Then now we can transpose the negative 10 to the left hand side, which is going to be negative 10 is equal to 0. So from there, we can be able to solve further, or to simplify further. That's 9x squared, 6 plus 6, which are like terms, that's 12. So we're going to have 12x, 4 minus 10, which is negative 6, is equal to 0. So that's our equation. But if you are to cross-check now on this equation, it was given in its simplest form, which means what actually took place, we just divided by the common term so that we can have that. So what is the common term? that we can actually use between 9, 12, and -6. The common term is going to be 3. So we're going to divide by 3 here, by 3, by 3, by 3. So that's, we are going to have our answer 3 into 9, which is 3x squared, 3 into 12, that is 4x, 3 into -6, which is -2, is equal to 0. So as you can see, we have managed to show that the equation can be written in this way. All right, so the other part now of the question after showing up is to solve that equation, giving your answer correct. Your answer is correct to 2 decimal place. Whenever you're given such a condition, it means we have to try by all means to use our quadratic formula. So depending with your method that is your best at, some are best at the quadratic formula, some completing the square. So you just choose the one that you are actually used to, or the one that you're best at. Okay, so I'm just going to write our equation here. I think it's going to be enough on this part here. So this was our item 2. All right, so the equation was solve the equation 3x squared plus 4x minus 2, the one that we managed to express up to this stage. Okay, so from this equation, remember our quadratic formula is going to be x is equivalent to minus b. All right, so I need to change this one. So we have got our x being equivalent to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. So in this case, we need the value of a, which is a is the coefficient of x squared. So a is equal to 3. Our b is the coefficient of x, which means our b is 4, and our c is the constant, and the constant is negative what? -2. So x is equivalent to minus b, that's our b here, which is -4, plus or minus the square root of b squared minus 4ac. So your b squared is 4. So it's going to be 4 squared minus 4 times a, which is 3, times c, which is the constant of -2. So that's what you're going to have, everything over what? 2 times a, which is 2 times 3. So that's what you're going to have. So you can simplify further. Remember what I always say, guys, that if you're dealing with the quadratic formula, make sure you simplify this part under the bracket, under the square root, I mean. So from this part under the square root, what are we going to have? So it's going to be the square root of, so this one you can even use your calculator. That's 4 squared, so you can even put in bracket 4 squared minus 4 times 3 times -2, like this. So you're going to obtain 40. So this will be the square root of 40 over 2 times 3, which is 6. So from this part now, that's where you can separate. Since we can't determine the square root of 4 direct, we are going to separate this into 2. X, which is equal to -4 plus square root of 40 over 6, or another x, which is equivalent to -4 minus square root of 40 over 6. So that's what you're going to have. So from your calculator, it's just the issue of inserting the values. Fraction here, got -4 plus the square root of 40. So this is square root of 40 here, just put aside. Then we divide by 6. All right, so you're going to have this, but if you convert this to a decimal, it's going to give us 0, so our x is going to be 0,3874, something like that. Or another x is going to be, we just have to change until we have got a negative in between, that's a plus now. Okay, so as a decimal, it's going to be 0,3. That is the one that we started with a positive, guys. Okay, we need a negative now. I wonder what's happening now. Okay, so we need a minus. So this will be -1, -1,7, 207, something like that. So therefore, x is equal to 0,387, or another x is equivalent to -1,72. So it's going to be -1,72. That is to 2 decimal place. So take note of the degree of accuracy that you'll be given, because it's the one that you're going to use to answer the typical questions that you'll be given. So I think, yeah, that's what we just did. Yes, just a matter of working different types of questions now, which can actually help. All right, so in this case, we are having construction, which is part of construction, which is actually one of the important parts, because you're going to have this question in our exam, and we just have to revise because it's there, it's already there. Our construction is already there. All right, so in this part, we are given to answer the whole of this question on a sheet of plain paper. Use ruler and compasses to show all constructions, lines, arcs, all constructions should be in a single diagram. Okay, we're given that there's a secondary school, which is named Boterekwa, is to be built to service 3 primary schools, Tugwi, Shinga, and Hlangu. Shinga is 16 kilometers from Tugwi, on a bearing of 150 degrees, and Hlangu, 15 kilometers northeast of Shinga. So that is the information that you're given. So what you're going to do here is to make a sketch. In order for you to draw this, we actually need a sketch, the one that you're going to work with, in order for us to at the end up having our constructing the actual diagram. But we actually need to have a sketch, which is the best way. So we are just going to have a sketch using the idea of bearing, because here it's under bearing, so you're supposed to use everything under bearing. All right, guys, so let us just sketch aside here. We're just going to put our sketch maybe somewhere here. All right, so let me, okay, this side, no, this side, let us just put it here. Okay, let me even maybe just remove this part, maybe it can help us. All right, this page. All right, so okay, so this is what you're going to do. We are going to have our sketch. So take note, guys, we are given that a secondary school, Boterekwa, is to be built to service 3 primary schools, Tugwi, Shinga, and Shinga is 16 kilometers from Tugwi. So remember, bearing, you start from. So we're given that 16 kilometers from Tugwi. So which means our bearing has to be from Tugwi, which is on a bearing of 150 degrees. So remember your bearing, guys. So you said we are going to start from Tugwi. That is where we are going to have our North Pole. Okay, so I'm just going to change here. Okay, so this is what you're going to have. Just have your North Pole. This is a sketch, guys, that you're going to have. So this is the North Pole, which is at Tugwi. So this is T, which is for Tugwi. Okay, then we are having a bearing of 150. So 150 is somewhere in between these two quadrants, because we've got 90, 180. So it's somewhere here. That's where we are going to indicate or represent our 150 degrees. Okay, that is from Tugwi. Where are we going? To Shinga. Yeah, Shinga is 16 kilometers, but take note here, we are given 1 centimeter to represent 2 kilometers. So that means 16 kilometers, we just divide by what? By 2. So it's just going to be 16 divided by 2, which is 8. That is the answer there. So as you can see, it's 8. So that means we are going to have 8 centimeters on our sketch. All right, somewhere here. Okay, so we're going to have 8 centimeters. Okay, so let me indicate the marker that I want here. Okay, so you said we are going to have 8 centimeters. That is, which means where we are going here, we are going to be at Shinga now. So we're going to indicate a North Pole at Shinga. All right, that is the idea there. Okay, so then let's move on to the other part. Then we are given that Hlangu is 15 kilometers northeast of Shinga. Take note, it is on the northeast. Northeast, that means we are talking about in between the north and the east. Okay, but it's 15 kilometers. So 15 divided by 2, which is going to give us 0.07,5, because it's 15 divided by 2. Okay, and this is going to give us an answer of what? 15 over 2, which is 7.5 centimeters. Okay, so this is 7.5 centimeters. But take note, guys, we are given that it's a northeast. Okay, so northeast meaning to say it's in between. This is your north here, this is your east. So in between the north and the east, that is where we are going to have it somewhere here. So it means we are going to have a special angle that is going to be in between here, which is 45 degrees and 45 degrees. So the northeast, it divides into 2 equal parts. So this one is from your compass bearing. Okay, but the angle is 45 degrees. Okay, so which means where we are going to reach here, we are going to reach the final destination which is our hlang, which is north here. So this is where you're going to have our hlang from. Okay. So guys, as we are having this sketch, we are supposed now to represent this with a bearing now. That is the one that you're supposed to sketch here to construct the diagram to show the portion of the 3 primary schools. Okay, so this is what you're going to do from our sketch. I want you to take note, guys, whenever you are indicating a north pole, okay, whenever you are indicating a north pole, this one at T, north pole, you are supposed to indicate that one as your 90 degree. The way that you construct 90 degrees is the same way that you're going to construct north pole, because this is bearing, but you're supposed to use the idea that you know from what? From basic construction. Okay, so these are the instruments that you're going to have. So using our ruler here, we are just going to draw a line because we want to have, I think this one is too big. Okay, it's too big actually. I'm just going to maybe somewhere here. Okay, so this is just a line that you're going to, where we are going to construct our 90 degrees. So it's not going to be that much. Okay, so on this line, guys, remember what I told you. For you to have 90 degrees, you're just going to mark a point of your choice, which is the one that you're going to use as your reference point. So here, I'm just going to mark a point here to say this is the point where I want to have my 90 degrees from. Okay, so now from this point, remember what we said, guys, we're going to mark 2 points. From that point of your choice, we're going to just mark anywhere, maybe somewhere here, you mark a point, all right? Then on the other side, again, you mark a point. So from these 2 points, you're going to step at one of the points, open more than half, like this one is more than half. You mark an arc on top. Remember, you want 90 degrees, so you're going to mark an arc on top. You do the same from this arc here, but now on the other side, like this. Okay, let us just be specific here. So don't change the distance that you're having. Okay, then you mark your arc like that. Okay, so there's no need for us to have, yes, we can have 2 arcs there, but just 1 arc is fine. This is a north pole, so it's not supposed to be broken. It's supposed to be direct, continuous as it is. So it's going to be 270. I mean, sorry, it's going to draw a straight line here. Okay. Let us save our marker here. So this is a north pole, let it be continuous. We're just going to draw a continuous line like this, okay, to indicate that it's a north pole. Okay, so this is how you construct a north pole. So we have our north pole, which is at T. Okay, so this north pole is at 2B, which is our T here. All right. But if we are to cross-check on our diagram, from 2 here, we are supposed to have 150 degrees. Okay, so 150 degrees, how are we going to construct the 150? That is the question now, this one that we are having here. We need this 150 degrees. Okay, this is what we are going to simply do. Because we know that from a straight line, we are going to have 180 degrees. This is what we know from a straight line. So it means the remaining angle that we have here is going to be 150 from 180, which is 180 minus 150, which is 30 degrees. Okay, so we are supposed to construct 30 degrees, but I want you to see something here. This is 90 degrees. The whole of this quadrant here is 90 degrees. So this is 30. And this is 60, so that it can give us 90. 60 plus 90 is that. So what I'm going to simply do is to construct 60 degrees from this line like this. If I am to construct 60 degrees from this line on this one, it means I have constructed 150 because this is 90. So 90 plus 60 gives us what? 150 degrees. So what I'm going to simply do is to construct 60 degrees. Then I know that I have got 9. Instead of constructing 30 balls, remember, for you to construct 30, you need 60 degrees, of which is a waste of time because we can just construct that 60 degrees direct here. So this is what I'm trying to say. On this line that we are having, let us construct our 60 degrees here. Okay, sorry for that. I just hope it didn't affect everything there. Okay, guys, right. All right, so we've got something like this. I'm just going to shift a little bit. Okay, guys, all right. So we had got something like this, guys. Now these arcs, they are being taken away, but this was 190 degrees. So just sorry for that, but as you can see, guys, it's taken away. Okay, so how do you construct the 60? This is what you're going to do. Remember, for you to construct 60, you need an arc, which is like just like a semicircle. but not that a semicircle, just a piece of a semicircle. Okay, so this is what you're going to do on this side, because our 60 has to be that side. Okay, so you construct it on this side. Okay, so this is our arc that we are going to work with. All right, so with this arc that we have drawn, remember your 60, we are going to step at this point without changing the length. We have to construct back the arc on this line. So without changing the length, if we have construct back here, as we can see, these two, they meet at a point like that. So these points meeting here, it means we can be able to join the two. By joining these two, we have constructed 60 degrees, and by constructing 60, it means we have got 150 degrees. Okay, guys, so let me just reduce this ruler a little bit. Okay, so I'm just going to shift it. Okay, guys, this ruler is still big. Okay, I hope like this. I want this to be small. Okay, so at least like this one is fine. Okay, so let us shift so that we will be able to draw, to join here. Okay, guys, just sorry for that, because here I'm not having your direct instruments like the ones that you're having here. It's electronic, guys. It takes me some time, but I just hope we are together there. All right, so which means by joining this, I'm going to have 60 degrees. By doing this, I'm having 60 degrees. Let me just adjust a little bit here, like this. I just hope it's not going to affect our line. Okay, so this is my 60 degrees that I'm having here. Okay, so that means from this part, if I am to say this is 60 degrees, of which there's no need for me to indicate that this is 60. I just know this is 60. By knowing that this is 60 degrees, it means the whole of this angle, 90 degrees plus 60 degrees, is going to give us 150 degrees. So that's how you construct 150 degrees. Okay, then from there, we are given that from this from this part that we are given, which is our T, up to S, which is our shinga here, it's 8 centimeters. So you're supposed to measure 8 centimeters, but guys, because of the movements that I have done, like all these movements that I have done, it's not going to give me the exact 8 centimeters. So I'm just going to use the one that I'm having. Maybe it's something like this. It's 8 centimeters here. So I'm just going to use this one. Okay. But you're supposed to measure correctly your 8 centimeters. Okay. With that 8 centimeters, you mark an arc. Okay. So I'm just going to mark an arc on this line like this. So it means this is where I am supposed to have my shinga, which is this one. Okay. This is your shinga here. Okay, let's get back to our diagram and see what is happening at shinga here. At shinga, we are supposed to have a north pole, just like what we did on Tugu here. We had a north pole, but how are we going to have our north pole? We are going to use now the concept of our parallel lines, because these are north pole and these two lines, they are parallel like this. So it means for us to have a north pole, we are going to construct this angle here. This angle of 30 degrees has to be the same as this angle. It must be also be 30 degrees. So if we can construct 30 degrees on this line, it means we are having what? A north pole. So the first thing is to have a north pole. So you're supposed to construct that. If this is 30, this is also 30. Or we can just say if this is 150, therefore this is 150. Okay, but the 30 was the easiest way. So we're going to focus on 30. All right, so this is what I'm trying to say. At this point where we are now, we are going to construct 30 degrees here so that we can have our north pole, because we say this is 30 degrees here. So this angle somewhere here, somewhere like this, it has to be 30 degrees. But you don't just draw this line. You're supposed to construct that 30 degrees. Okay, so that is the purpose that you're supposed to do. Okay, so to remember how you construct 30, you're supposed to bisect 60 degrees. So you're going to construct 60 on this side. Okay, so your 60, remember how we constructed it. We said we need an arc, a semicircle. So you're just going to construct like a semicircle, just an arc like this. Okay, then from the arc that we are having, this one, we are supposed to mark back from this point here. Okay, where these two meet, you mark back to the what? To the arc again like this. This is your 60 degrees. Okay. But since I know that I'm going to have 60 degrees from this arc, there's no need for me to join. I'm just going to step at this point again, bisect the angle. So that means I'm going to bisect it this way. I'm going to mark an arc in within this space and do the same on the point of intersection. Here, step, you need to point on the point of intersection of the arc. Then you mark an arc back to the inside here. These two arcs, they must meet at a certain point like this. So it means truly we have our 30 degrees. So this was 60 degrees and this is now 30 degrees. So by joining this, we are going to create an angle of 90 degrees, which means we are now having what? A north pole. So you just join straight to the line like this. As you can see, truly it's a north pole, this one. As you can see, it's a straight line that you're creating. So you join the two, that means we are now having a north pole at this point here. This will be your north pole, okay, like this. So that is what I'm trying to say, guys. So this is 30 degrees, this is 30 degrees, and this makes this to be a north pole. And we are said this is our shinga. And between Tugu and Shinga, we said it's 8 centimeters. So you just measure, just write your 8 centimeters here. Okay. So now we have got a north pole, but we do not have the line which like this one, which goes to the east. It was an advantage because this was your reference, your starting point. So you just drew this line. But here we can't just draw a line like this to say, okay, we need the line that goes from the west to the east. Then we just draw like that. No. What are we supposed to do? We are supposed to construct directly 90 degrees, the way that we construct 90. Remember how you construct 90? We are going to step at this point. Remember your 90, you just mark 2 points from that one. So I'm just going to use this one. And you mark an arc on this point. You mark another arc on the other end here. Okay, so from the two arcs that we marked, this arc here, and the other arc, we just open more than half of the line like this. We've opened more than half of the line. Okay, we are supposed to mark an arc on top on this side. So we're going to mark an arc on the top here and also another arc on the other side. We can't say, is this the top or just the other side? Okay, the other side and the other side. Okay, then from the other arc here, I'm going to place on this arc now, mark back the arcs, so which means I have to mark back here like this. So I have an arc here that I've marked. I'm supposed to also mark on this side. As you can see, they meet at this point. Okay, so these two arcs, they meet. So by having these two arcs, I'm just going to join them. I'm now having my what? My 90 degrees. So this is at 0 here. Okay, like this, if I join, they are going to pass through the center, and truly they do pass through the center. So this is your east from west, this line that you have drawn. You've drawn a line from the east to west, which means we have got a complete north pole. It has got north, west, east to south. Why do we need this? Because it is important here. If you are to cross-check, remember we said we need an angle of 45 degrees. So if we've got this, we can bisect now the first quadrant, because this is in the first quadrant. Remember, it was northeast, northeast. So it's in between the north and the east. So we bisect in the first quadrant, which means we are going to bisect here. This is what you're going to do. Okay, I'm just going to move it a little bit here. We are going to bisect this angle here of 90 degrees on this quadrant with the north and east. Remember, this is your east here. So you're going to bisect that quadrant. Okay, so let us bisect the angle of 90 degrees. Sorry. To bisect 90, guys, is usual, just the way that we do. Remember, we have to step at this point at the center. Okay, we mark two arcs from that center. So I'm just going to mark two arcs of my choice. I'm just going to change a marker here. Let me use the red one. Okay, so I'm going to use this one in red. Mark an arc on this line. Also, you mark an arc on this line like this. Okay, so these are the lines that are actually giving us an angle of what? An angle of 90 degrees, these two arcs. So those are the arcs that you're going to mark. Okay, so from these arcs that we have marked here, we are going to mark from those arcs, which is these ones, this one in red and this one in red. Okay, so we're going to mark an arc from these two like this without changing the distance. Now we are marking an arc inside the 90 degrees, somewhere that we expect to have our bisector. So you can even mark from this one like this. We can mark from this arc like this. Is an arc here. All right, we do the same from the other end, from the other arc. So which means this is the other arc here. So you have to mark from this arc to this side. Okay, back to this arc here. I'm going to mark it like this. Okay, truly they do meet at the certain point. Yes, so I'm going to join those points. All right, so this is what I'm going to have here. Okay, so somewhere here I'm going to join these two. So you can see they are going to meet at a certain point. Okay, so join these ones up to the end. Okay, we're just going to join. I don't know where it is going to meet, somewhere there. All right, let me, okay, a little bit like this one. Okay, so this is what you're going to do. You just draw. So, which means here we are going to have 45 degrees, also 45 degrees here. This is Shinga, but we are told that from Shinga, where are we going to we are supposed to go to Klang. And Klang here is 7,5. Remember, we divided here. We divided this 15 and we got 7,5 from this 15, which is in the northeast. We got what? 7,5. So it means we are supposed to have 7,5 from that region here. Okay, we are supposed to have 7,5 here. Okay. But now what I'm going to do, guys, I'm just going to remeasure this because it's supposed to be the same. Remember, we need 8 here so that we can have direct actual dimensions. Okay, so our 8, I'm just going to step here. Okay, this is what 10 commas. So I have to reduce again, guys. I have to reduce again until I get the sketch. But now because of time, guys, because here I have adjusted this and that, so it's not going to give me the exact thing. As you can see, this one is 6 centimeters. So it's not going to give me the exact thing. So guys, because of time, I'm just going to mark an arc, okay? But on your actual thing, guys, you're supposed to measure, okay? Measure 8 centimeters, then 7,5 centimeters, then you mark, okay? But in this case now, because I've been affected by what? By this part of zooming in and zooming out. So anyways, this will be my 7,5. I'm just going to mark, and I don't know exactly where was it going to be according to your diagram. Let's just say it's here, okay? Let's just say it's going to be somewhere here. That means that's where our Klang is going to be. So on your diagram, if you measure 7,5 direct on your diagram, this is your 7,5, you've measured properly. This is going to be your Klang. So at the end, there's no need for you to have a North Pole, a Klang. No. That one, there's no need. You can just join. Since it is the last point, there's no need for, yes, you can have a North Pole there, but actually there's no need. You just have to join the rest. Okay, so this is what you're going to have like this. So at the end, your diagram was going to look like this. Okay, so guys, this is how our diagram was going to look like at the end from that sketch. You join the last part of your bearing like this. So let's just, hope that we have a nice diagram, which is more clear than this one that I'm having here, but that is the idea there. Okay, so let us get back to our questions and see what we are given. The first question is, Boterekwa is 80 kilometers from Shinga and equidistant from Tugu and Klang. Construct the locus of points 80 kilometers from Shinga. So 8 kilometers, you divide again by 2, which is 4 centimeters. So from Shinga is a point. Remember, guys, locus of points equidistant from a fixed point. That one, it's a what? It's a circle. So we need locus of points equidistant, which is 8 kilometers from Shinga. So that is the first question. So 8 kilometers is a circle. So you're going to draw a circle from Shinga, which is 8 meters, 8 kilometers. So you divide by what? You divide by 2. All right, so let us get back to our diagram. Our diagram is a little bit far. Okay, so it's here. So like I said, guys, on your measurements, you measure 4 centimeters, you construct a circle depending with where it is going to be like, but here it's going to be somewhere here. Then I draw a circle at Shinga, not Klang. All right. So this is supposed to be here, guys, at Shinga, not Klang. All right. So it's supposed to be here at this point at Shinga here. All right. We draw our circle like that. So this is the locus of points 4 centimeters from S, which was 80 kilometers from what? From Shinga. Okay. Then what is the other question? Let us get back to our question. Okay, let us get back to our question and see what you're going to have here. I just hope, okay, like this. All right, so on our question back, you are now given, and also the locus of points equidistant from Tugui and Hlang. So it's Tugui and Hlang. So which means Tugui and Hlang, you bisect. Remember, guys, locus of points equidistant from A and B. I told you, you bisect the line. A and B, it's a only line, so you bisect the line. So it's the same Tugui and Hlang. These are points which are on a line. So you simply bisect from Tugui to Hlang. Okay. So you're going to have a line, so you bisect from that one. Okay. I want that diagram. It's somewhere here. Where is it? Okay, guys, let's just hope it's not going to affect us much of our time. Okay, let me just shift. It can waste us time. All right, so we said we need Tugui and Hlang. Okay, in between these two, all right, let's reduce so that we can see our diagram here. All right, so this is our diagram, guys. So we need Tugui and Hlang in between here, Tugui and Hlang. So a bisector, it means you're going to do this to bisect a line. Remember, you're bisecting a line. So you just open more than half of the line, okay? So remember, you open more than half of the line. You mark an arc on top, then another arc in the bottom, just like what you do, guys, on your normal bisection, okay? So this is more than half, as you can see. I just mark an arc on top here and another arc on the downside here. Okay, somewhere there. Then from Tugui, I do the same again. I have to mark an arc back here. So as you can see, yes, they are going to meet at this point. Okay, I do the same here, so which means I'm supposed to mark back to this side here. Okay, so I'm just going, I want to shift this, okay, but without changing the point, I'm supposed to mark this side. Okay, so they are going to meet at this point. Okay, so that's it. I have my points. With these 2 points, you're supposed to join them. All right, so let's just join our points here, guys, so that we can see what we have. And also try to increase this line that you're going to use whenever you're joining, whenever you're using a line, try to make sure that you draw a big line like this one, extend it like that. Okay, so I'm just going to draw my line. So this is the line I have bisected from Tugui to Hlang. Okay, so this is what is going to happen, guys. We are going to have 2 possible positions. All right, so that's what you're going to have. Now it is zoomed a big. Okay, so it's just like that, guys. You've bisected your line. Okay, so the other consideration now was for us to mark and label the points B1 and what and B2, which are the possible positions of what Boterekwa. So Boterekwa is actually, we are told it is equidistant, which is 8 kilometers, and that one. So which means we need where we had a circle. Because equidistant, or the first one was a circle and the other one was like this. So these are the 2 possible positions. So on our diagram, we just need those 2 possible positions. We mark them and we name them B1 and B2. That was the case. Okay. So where are we having it? So according to my diagram, guys, this is where I'm going to have it. So like I said, guys, it depends with actually how your diagram is going to be at the end. But according to this diagram, we are going to have B1 and B2 at this point. Where the circle and what and the line meets, I think is somewhere here. Okay, see, I think here. So you see this point at this point. Okay, so you'd mark those points like this one. You just name it B1. You mark also this one. You call it B2. Okay, so that was the consideration of the question. Mark and label. So it's not about just marking the points, but you're supposed to mark, then label the what? Then label the points. Okay, so that was the it for this part here. Then let's see the other part, which is the last part of the question. And now saying use your diagram to find the shorter distance between Boterekwa and Tugui. So we need the shorter distance between Boterekwa and Tugui. So what you do is that this is your Boterekwa here. We are talking about 2 positions that we can talk of here. The B1 here, this B1 and this B2. These are the possible positions, this B1 and this B2. So which one is the one that is closer to Tugui? By just looking at the diagram, you can see that This is the one that is closer, the B one, this one is closer to 2 here. That is what they say. So they are saying measure that distance and write the actual distance. So what you do on your B1 here to T, I want you to measure this distance. You can put even your divider, then you on your ruler, or just use your ruler, direct, measure that distance. If you measure, your answer is going to be in centimeters. Then you have to convert to kilometers, because we are told that a kilometer is being represented by what? By 2 centimeters. So you have to multiply by 2 centimeters by 2 in order for you to have your answer now in what? In kilometers. You just use the ratio that you are given there. Okay. So that was the easier way, guys, that we could have constructed 1 centimeter to 2 kilometers. Is 1 centimeter to 2, guys. This is 1 centimeter to 2 kilometer. Okay. Let's just hope we correct this. So it's 1 centimeter to 2 kilometers. So maybe you get 5 centimeters, you multiply by 2. Whatever that you get, you multiply by 2. It will be in what? In kilometers. So that was the case, guys, on your construction. I think with this information, yes, we can answer as much questions on bearing as we can. It's all about the sketch. After the sketch, make sure that the diagram is clearly presented or clearly what? Drawn. It can make things easier, just like what we had from this diagram. Okay, so I think with this we can move on to the other part of the question. So this one is a given. We are given matrix. These are now matrices. There we are given matrix A. Find the inverse of A. So guys, as you know that the inverse of a matrix is supposed to be from the determinant first. You're supposed to find the determinant of A, whereby the determinant of A is the product of the major diagonal minus the minor diagonal, provided that your matrix is written in the form of A, B, C, D like this, which means it's going to be AD minus BC. So that means the determinant of A, in this case is going to be AD minus BC, which is 3 and negative 2. So it's going to be 3 by negative 2 minus B and C. This will be minus 4 and 1. So it's going to be minus 4 by 1. Okay, 3 by negative 2 is negative 6 minus 4 by negative 1 is negative 4. Okay, so on your calculator, you can simplify. This is negative 6 plus 4 minus and a plus, that's a plus. So you can simply subtract, yes, minus 6 is going to be a negative. Okay, what is happening with my calculator? Sorry. So it's going to be a negative 6 plus 4, which is plus 4, which is a negative 2. So you're going to get negative 2 from there. All right, so this is your determinant. Then the inverse, remember the inverse is 1 over determinant. So it was supposed to be 1 over minus 2. Take note how it was supposed to be. It was supposed to be 1 over minus 2. All right, so from there, if it was supposed to be 1 over minus 2 like this, but we know that the negative is supposed to be written on top. So it's going to be negative 1 over 2. And what happens? Remember the numbers in the major diagonal, they interchange their positions. So this will be negative 2, 3. In the minor, you multiply by a minus. So this is minus 4. You multiply by a minus, minus and minus, that's a plus. Here we multiply by a minus, so it's minus times 1, which is minus 1. Okay, so that is the inverse of A. So I think from this part it's fine. Then hence or otherwise solve the equations. Okay, so the hence here it's a continuation. Otherwise, that is, you can use any method. So the hence was on matrix method. Since we have find the inverse here, which means we are supposed to apply or to use matrix method. That was the hence method. Okay, so how do you apply the matrix method? What does it state, or what does it, how do you use the matrix method? Okay, the matrix method, we know that for us to solve, we are going to rewrite this in matrix way, 3 minus 4, and this in matrix way, so it's going to be 3. So this is item 2. All right, let me change to another one which is clear here. All right, so this is our item 2. So like I said, you're supposed to write this in matrix way, the equation. So you write 3 and 1 in a matrix way. So this is a 3 and 1 in a matrix way, minus 4 and minus 2 in a matrix way. So it's minus 4 minus 2 in a matrix way like this. We multiply by x and y, which is the variables that you're given. Whatever that you're going to get is minus 3 minus 2. So you use minus 3 and minus 2 in matrix form. So it's going to be equal to minus 3 minus 2. So this is the format that you're supposed to have. Then from this matrix method states that for you to solve for x, you're going to find the inverse of this matrix here. You have to find its inverse, okay? Find the inverse. All right, with the inverse that you have found here, of which is this one that you have determined, we are supposed to multiply with the inverse both sides of the what matrix. So this is your inverse that you've got. You use it minus half, minus 2, minus 1. Since it is a hence method, there's no need for you to start again to find the inverse. So this is your inverse times everything as it was 3, 1, minus 4, minus 2, multiplied by xy is equal to the same inverse. You multiply it on the other side. So it's going to be minus 1 over 2 into minus 2, minus 1, 4, 3, multiply by minus 3, minus 2 like this. Okay. Now, this is what you're supposed to know in this case, because you're multiplying the inverse of a matrix to its original matrix, which means you're going to obtain identity matrix. Remember your identity matrix 1, 0, 0, 1. So on this part here, you're not going to waste time multiplying these two. You know that they are going to give, it's going to give you identity matrix. So don't waste your time there. So it's going to be 1, 0, 0, 1. Multiply by xy like that. Okay, so this is what you're going to get. Then on the other side, there we are supposed to do the proper multiplication. So you're going to have your minus half as a scalar. So you've got minus half. Then you multiply as usual row by column. So you're going to have this row to the column. So it's negative 2 by negative 3, which is going to be a positive 6. Okay, plus this is 4 times minus 2. So 4 times minus 2 is negative 8. We move on to this row and then that column again. So it's negative 1 by negative 3, which is positive 3, plus 3 times negative 2, which is negative 6. Okay, so this is what you're going to have. And if we are to multiply here, identity matrix times any matrix, it remains as it is. So if you multiply any matrix by an identity matrix, that matrix will remain as it is. So this one is going to give us xy like that, which is equal to negative half by, we can combine 6 plus minus 8, 6 minus 8, which is minus 2. 3 plus minus 6 is 3 minus 6, which is minus 3. So what are you going to do from this stage? We have to multiply by the scalar now, which is negative half. So it's negative half times minus 2, which is going to give us a 1. Negative half times minus 3, which is going to give us 3 over 2, or it's 1,5 or 1.5, whatever that you're going to have from this part. All right, so that will be the condition. So what does it mean? It means, therefore, our x corresponds with 1. So x is equal to 1. Y corresponds with 1,5. So this was your hence method. The hence is a continuation from what you are given. Then otherwise, it means you can use any method of your choice. Okay, so what I want you to do is that from this question, I want you to solve this simultaneous equation using any method of your choice that you are used to, and see if you're going to have the same answers like the ones that we had from that part. Okay, so the B part was now on bearing. We are given that the diagram shows a trapezium. So this is a trapezium, guys, and you know that on a trapezium, these two sides, they must be parallel from O to C and from A to B. These two, they are parallel. Okay, then we are given vector OA and vector OC, which is y diagonals. OB, they intersected B, and say that DC S to AD, S to DC is 3 S to 2. So it's AD from A to D is 3 parts. D to C is 2 parts. So that is the ratio that you're given. Okay, so the first question, calculate or express in terms of X and Y vector AC. So from A to C, guys, as you can see, is simply a movement that you're going to take from point A to point C. So which means our AC, we can take the root from A to C is going to be AO plus OC. So this one is going to be AO plus OC. Remember, you take where the information is given. Okay. So let us have our vector. So vector AC is going to be from A to O. As we can see, guys, we are opposing the arrows. So it's going to be a negative. So it's negative X plus from O to C. It's a positive. We are maintaining the arrow. So it's going to be Y like that. Okay, so this is our vector AC. Okay, then we move on to the other part, which is AD, which is the B part, AD. So from A to D, we can use the ratio because we've got the ratio A to D is 3 parts. Out of AC, since we calculated AC, if you had to cross-check, AC is a combination of 3 plus 2. So it means AD, this is what you're going to have. AD is 3 parts out of 5 of the whole line of what? Of the whole line of AC. So it's going to be 3 out of 5 of the whole line of AC, of which we calculated AC before. So AD is going to be 3 over 5 times AC, which is this one that we calculated, minus X plus Y. Okay, so if we multiply by negative, by 3 over 5, what are you going to get? Our AD is going to be 3 over 5 times negative X is negative 3 over 5X. 3 over 5 times Y is going to be 3 over 5Y like that. Okay, so this is your vector AD. So just like that, guys, we are done. Okay, so it's actually something that you're supposed to work from. Okay, then the item 2, you're given that AB is KOC. So this is what you're given. AB is KOC, of which from O to C here it's Y. As you can see, it's Y. And then they are saying this AB is KOC. So it's K times OC, which is vector Y like this. This is your vector AB. Okay, so it means on our diagram, we have got AB, which is KY here. On our diagram, this is now KY. Okay, so the question is, using this information, express OB in terms of K, X, and Y. So we need vector OB. So where are we going to have our vector OB from? Okay, so this is our item 2. We need vector OB. So this is what you're going to do using the AB that we have indicated here, because now AB is KY. So from O to B, we are going to take this direction from O to A and from A to B. Okay, so it's going to be OA. It's going to be O to A. That is OA here plus AB. Okay, so I think we can have our OB from this part. Okay, whereby OA, from O to A, we are maintaining the arrow this time. We are going this direction, so it's a positive X plus AY, AB, sorry, AB, we are maintaining the arrow again, so it's going to be as it is, which is K vector Y. Okay, so this was your vector OB. We're done. Okay, then let's see the other part. We are also given another condition here, given also that OB is equal to HOD, expressed in terms of H and what, the same vector OB. Okay, but we are given that OB is HOD. Okay, so this is what we have here. OB is equal to HOD. Okay, do we have OD? That is the question that we are supposed to ask ourselves now. Do we have this vector OD? That is the question. Okay, so let's cross check if we calculated this before, or if we have, we do not have. So which means we are supposed to calculate OD because we do not have anything about OD. So we're supposed to calculate that OD first. And which route are we going to take? For us to have OD, we can take this route from O to A and from A to D. Since we have got vector AD here, we got our vector AD on this one. So OD is going to be OA plus AD. Okay, so that's OA plus AD. So we are supposed to calculate OD first. So we said OD is equal to OA plus AD. So this is what you're going to have on OD. So OD is equal to, from O to A, as we saw from our diagram, guys, that it was vector A, vector X. So I'm just going to take that one as vector X. So this is vector X plus AD. AD is the one that we calculated. So AD, remember OA, guys, from our diagram, this is OA here. It was vector OX here. OA is X. Then AD, this is the answer that you got, minus 3 over 5X. And 3 over 5y. Okay, so this is your answer that you're going to take. So we said we've got minus 3 over 5x plus 3 over 5 vector y. Okay, so collecting like terms, we are going to have, this is 1 minus 3 over 5. So on your calculator, you can simply subtract 1 minus 3 over 5. So this is 3 over 5 like this, which is going to give us 2 over 5. So we're going to have 2 over 5x plus 3 over 5y like this. Okay, so this is your vector OD. But here we are given that OB is equal to HOD. So now we can find our OB. So OB is equal to H times the vector OD, which is this one that you calculated here, 2 over 5 vector X plus 3 over 5 vector Y. So this is your vector OD. Okay, so that is at the end, you're going to have our OB by multiplying by H. So it's H times 2 over 5, which is 2 over 5 HX plus H times 3 over 5 is 3 over 5 HY like that. Okay, so this is the answer that we're supposed to get for vector OB from that information. So it was a continuation, it was actually a combination of two vectors. We are given two vectors that we are working with. And from those two vectors, we are saying which one are we going to use from those two vectors? That was the question. Okay, so I think this part was fine. Let us cross-check the other part. Now we are given on item 4, using the results from item 2. Item 2, we calculated OB here. And item 3, we calculated also OB. Find the numerical value of H and the numerical value of what? Of K. So we are going to take these answers that we got here, this OB that we calculated on item 2, and this OB that we calculated on the other item. So you write them down, okay? So I'm going to write them down here. Okay, I'm just going to write them down. So guys, just rewrite those values as they were, okay? As they are from that part, okay? So the first OB, remember, it gave us x plus ky. That was x plus ky like this. The second OB that we calculated now, it gave us 2 over 5. Oh, this was actually 2 over 5, not 3 over 5. So this is 2 over 5 hx plus 3 over 5 hy. All right, so these were the two equations that we had. Now we want to solve for h and k. So this is what you're going to do. If we are to cross-check, remember I told you that you're supposed to equate equal vectors. Here we've got a vector x. And what is the coefficient of vector x? There's a 1 here. So you're going to equate this one to the constant or the coefficient of what? The scalar of vector x here, which is 2 over 5a. So we've got an equation, 1 is equal to 2 over 5h. So this is an equation that you're going to formulate. Okay, we move on to vector y here. If we remove vector y, we are going to be left with k. So k is equal to, we remove vector y here, we are going to be left with 3 over 5h. So these are the two equations that you're going to have. So like I said, guys, under vector, if you have formulated these two equations, it's up to you to solve these equations. How are you going to do it? But here it was an advantage because if you had to cross-check the first equation, there is only one unknown, which is h. So I can take advantage of this. Since here we can cross multiply. Remember, we can cross multiply to remove fractions. So it's 5 times 1 here, which is 5 is equal to 2. 1 times 2h, which is 2h. So to find h, I can simply divide by 2 by 2. So therefore h is going to be 5 over 2. So this is vector. You can leave it as an improper fraction like that. Okay. Now I have got the value of h, which is 5 over 2. For me to have the value of k, since here on the second equation, as you can see already, k is the change of subject. So you can take advantage of that to say k is equal to 3 over 5 times h. And you have got that h here, which is 5 over 2. So you can take that as an advantage. So that means you can cancel the 5 and the 5 can cancel, and you're going to have 3 over 2. So k is equal to, because this is 1, this is 1, 3 times 1 is 3, 1 times 2, which is 2. So this is the value of k, and that was the value of h. Okay, so that was it, guys, on this part. As you can see, it was a little bit clear. All you needed here was to formulate the equations properly. That is the best thing that you could have done. So as you can see, guys, 7 marks just for that. All right, anyways, let us cross-check the other question. The other question, definitely, guys, as you know, transformation the issue of our diagrams, we need our diagrams to be done clearly. So a given triangle ABC, yes, good coordinates 2, 1, 4, 1, 4, 4, using a scale of 1 centimeter to length, 1 unit on both axes. So if they say 1 centimeter to represent 1, what does that part mean? In each and every centimeter is going to be 1, 2, but we know that the box, each box like this one is 2 centimeters. So it means 2 centimeters represent 2 units, because 1 centimeter is a half of a box. So 1 is just half of a box. So which means the whole box will be 2, 4, 6 on both scale 2, 4, 6 like that. Okay, so I think from this, it can be easier to grasp this question actually. All right, so already I'm having actually the graphs. I'm just going to show you what it was supposed to look like. Maybe it can actually help us to have. Okay, so I've drawn the first diagram, which is our triangle ABC and A2. Okay, these are the triangles which are already there. Okay, so we are going to focus on this one ABC. So take note about your scale. 2 centimeters representing 2 units on both axes. So you've got your X and Y axis here. If you are to cross check properly, everything is fine. All right, so we are going to start with the first question, where we are given on item B. This is our B here. So on our B, we are given that triangle A1, B1, C1 is a reflection. So take note, we are given that it's a reflection, and this reflection is happening in the line of Y is equal to -2. Draw and label clearly triangle A1, B1, C1. So take note, guys, we are saying this is a reflection in this line of Y is equal to -2. So all we need is to have the line of Y is equal to -2 first. Okay. So let us get to our diagram. We need line of Y is equal to -2, where Y is equal to -2 at this point. So we're going to draw the line at -2 and on the Y here. So it's going to be a horizontal line actually. Okay, so let us just try to have our ruler like this. Okay, so we're just going to draw our line here, somewhere here. So this is Y is equal to -2 here. All right, so this is where we are supposed to have our line being drawn. So I'm just going to draw our line here. That's Y is equal to -2. I can just use the red one so that it cannot affect the X and Y axis that we had before. Okay, so it's going to be like this. So all you need there actually is to draw your line first. So you're going to draw your line, then after that you can reflect. Okay, so also don't forget to write the equation of the line. So this equation is Y is equal to -2. Okay, so that is the equation that you're given. So take note, guys, this is a reflection, and I told you that whenever you're given a horizontal line or a vertical line like this, the distance that you move from the point to the mirror line, let's say this is your mirror line, you move the same distance to the mirror line, same distance from the mirror line to the image. So if this is A, this will be your A1. The same thing, if this is your A here, if it moves to this line, same movement downwards, this becomes your A1. So that is how you do it. So you're going to move according to scale. Okay. So this is what I'm going to do according to a full box here. I've got this is a half box from A to the x-axis. I've got a half box here, then a 1 box which is complete. So which means I've got 1.5 box. So I'm going to do the same. I'm going to move 1.5. So this is 1 box here which is complete, a half which is somewhere here. So where I reach, I mark a point. So this will be my A1. Same distance that I've moved from the object to the mirror line, from the mirror line to the image, direct like that. Okay, you do the same on B. You move, this is a half box plus 1, so it's 1.5 box. So it's going to be 1 box from the mirror line and a half box which is here. So this is going to be our B1. Okay, we do the same from C. So from C to the mirror line is going to be 1 box, 2 box, 3 boxes. So these are 3 boxes to the mirror line. So which means from the mirror line going downwards, we are supposed to move 3 boxes. This is a mirror line, we're going to move 3 boxes. So that is 1 here, 2 here, and 3 here. So this is where we are going to have our C1. At the last point, you can join those points. Okay, so now we can join our points, guys. This will be our image for A, B, C in that line. Okay, so I'm just going to draw here so that it can be easier for us. Okay, so let us see, have our diagram. As you can see, guys, that is your reflection. That's how you simply reflect the given shape that you are having. All right, so here we are going to just join. It's a matter of joining, guys. As you know, my instruments, they take a little bit time to be accurate, but that is the idea there. All right, so just joining these points, that's our triangle that you're going to have at the end. So this is a reflection of the line of the triangle that we had before, which is this supposed to be, let us count again, guys. We said 1, 2, 3, and this is 1, 2, 3 supposed to be here. Okay, so this our C is not exactly where it's supposed to be, guys. You see this issue of these instruments, I'm suppose like these boxes, there will be something like difficult for me to handle. So it's going to be 1 here. That's 1, then 2, 3. So our 3 is here at -8. Okay, so this is where our 3 was supposed to be, like this. Okay, so our 3 was supposed to be at that point. Okay, so you can name this was our C1. Okay, so this was C1. Now we can join our points. Okay, so that is the idea there. Can join your points. All right, so it's not going to waste us much time here. Okay, let me just put it this way. Okay, so like this, guys, we have our triangle. Now it can make sense even if you can cross-check at our shape, the way that it looks, because remember, this is a reflection and these are isometries. So just make sure that you move properly. There it was because of these boxes, you know, they are too close to each other, but that is the idea. So you can see the object that you have here and the image are actually the same. So you move same distance from the point, which is your object, to the mirror line, from the mirror line to the image, straight like that. Okay, so that is what you do whenever you're given horizontal and a vertical line. In this case, a horizontal or a vertical line. Okay, so that was the case. Let us cross-check the other question. On C, so we are now on C. That is where we are being given triangle A2, B2, C2 as vertices at. These are the vertices. So as you know, guys, you just mark the points, then you join. Draw and label triangle A2, B2, C2. So this is the one that I've already drawn here. So as you can see, guys, a matter of marking your points, the one that you're given, then you can join. So this is A2, B2, C2, not 10. This is C2, guys. I don't know what was happening there. So it's C2, this one. All right. So we have drawn our triangle, is there. Then what is the question? Let us get back to the question. The question is, from that, describe the single transformation that maps triangle ABC onto triangle A2, B2, C2. Okay, so let us cross-check our diagram. This is what I want you to do when you are describing. It's a stage-by-stage type of a question that you're supposed to analyze whatever that you're given. Okay, from the object ABC, this one, we can see that this AB, this side, it was just a 1 box, as you can see. Now we have got 2 boxes, which means we can't be talking of rotation. We can't be talking of, the moment rotation is not there, reflection is not there, translation also is not there. Why? Because I told you these are isometries. The object and the image are the same. So which means we are going to expect our answers to be under the other 3 isometries. But on those 3 isometries, which is here, because I've done all these now, so you can understand this stretch and enlargement. Remember, on stretch, we've got 2, we've got 1 way and 2 way. Shear is going to be out because, as we can see, guys, we have increased all the sides. B to C, it was increased, A to C, it was increased. So which means the shear is no longer there. And I told you that whenever you're talking of shear, if shear is not there, it means one-way stretch is not there. So these 2 are not there. One-way stretch and shear is totally out. So we are now left with the stretch of 2-way. We are now left with 2-way stretch and enlargement. So these are the 2 answers that you are going to expect to have. But remember what happens on enlargement, and also on the other part also that I told you is that there's no way that they're going to give you 2 stretch to describe. So it's going to be an enlargement, definitely. Okay, anyways, let us see how it's going to be. Let us check, because we are now left in enlargement and 2 stretch. So this is what we're going to verify. You start by verifying, is it enlargement, because it's the easiest one for you to verify this one. Then if it is not enlargement, therefore it is a 2 stretch. So that's the easiest way that you can do. Okay, so this is what you do. You measure your sides, okay? By just looking some of these sides, you can even tell. Let us start with A2, B2. From A2, we said there are 2 boxes now, and here it was 1. So which means we increased this one by 2. This one was just 1 box. These are 2 boxes, okay? The same which is on C here, you can even use your divider. Also, that's the easiest way that you can do. Again, you can take your divider like this. I just want to insert a divider so that you can understand what I'm trying to explain. So divider or compass, these are the easiest ways. These are the easiest instruments that you can actually use. Okay, so here we just have compass, which means you're going to use a compass. Okay, so this is what you do with the compass. You place it this way. All right, then you place this one at, we want to measure from what? From B to C. Okay, this is our B to C. This one, as you can see, these are the dimensions of B to C. These ones that we see here. This is our B to C, the one that we are given. I'm just going to increase a little bit here so that it can be exactly where it is supposed to be. All right, somewhere here, as you can see, this is your B to C. Now you want to see how many of these are in B2, C2. So this is what you do. You just take your instrument back to B to C. As we can see, to this point here, it's 1. To this point here, we've got 1 BC here to this point. So I'm just going to mark at this point, we've got 1 BC. Okay, we move on again. We have got 2 of them, as you can see. So which means this BC that we have, it's 1 here and here, there are 2. Okay, we confirm the last one, which is A to C. You measure from A to C. This is your A to C. You just put your compass there or your divider, depending with which one is best for you. Okay, so you're going to place it here. Then you open this distance because you want to measure this. Okay, so this is 1 AC. So according to AC, we have got 1 AC. But how many ACs do we have from A2 to C2? How many of them are there? Let us cross-check. We're going to put here, this is 1 of it, which is this one. So we put 1. Then we place it from this point to this point. As you can see, there are 2 of them. So because this distance that we see, it represents what? AC. So from A to C, we've got 1 of it, but in A2, C2, which is your image, there are 2 of them. So as you can see, guys, we increased AB 2 times. We increased BC 2 times. We increased AC 2 times. So that one is an enlargement. Enlargement, all sides, they are being increased proportionally. That's proportionally. Okay, just let's hope my spelling is fine. So proportionally meaning to say by the same scale factor. Enlargement, what happens if it was a 2-way stretch, you were going to see that maybe on the other part you increase by 2, another side you increase again by 2, another one maybe you increase by 3. If you see these differing like this, therefore that one is a 2-way stretch. That's how you can see that, okay, this is a 2-way stretch, because you are increasing differently. So it is going to have 2 scale factors, which is 2 stretch factors. But in enlargement, you increase proportionally like this. So this one is an enlargement. As you can see, we have proved it was increased by 2, by 2, by 2. So we can describe now, because our question was for us to describe. Okay. So let us describe. We can even put it here. Okay, I've increased too much. I don't know, maybe somewhere here. Okay, so we can now describe our transformation. So this is C item 2. Okay, so C item 2. It is an enlargement. Remember, when you're describing, so it is an enlargement. All right, so remember on enlargement, you must find the center of enlargement and the scale factor. So these are the 2 things that we are supposed to find: the center and the scale factor. So where do we find the center? Remember, guys, what I told you on enlargement. For you to find the center, you join the corresponding points up to where they meet. That's your center of enlargement. So I'm going to join from A to A2, from A2 to A like that in a continuation, like that. Okay, so it must be a continuation from A2 there to A like that. Okay, so maybe I can just increase to this side like this a little bit. So because we do not know exactly where it is going to reach, so make sure that your ruler, you increase it so that it becomes actually fine. Okay, so this is what I'm going to do. I'm going to increase this line again. Okay, so you just join. Let me just choose another marker which is not familiar with what we have there. So maybe let's just use the red one, it's fine. So let us join, guys, from A to A2. You can even use broken lines, okay? Just use broken lines since you are joining. So you can just use broken lines, okay? You join from A to A2. All right, it must pass through A2 like that. Okay, so that's it. From A to A2, you move on from B to B2. So these, they must meet at one point, all of them, if truly it is enlargement. So this is B to B2. All right, that's somewhere here, just a little bit. Okay, that's B to B2. Let us increase again. So you join B to B2. So this is what it's going to look like, B to B2. Okay, you do the same even with the C to C2. So this is what you're going to do. You're going to join also C to C2. But by joining that, you're going to see definitely it is going to pass through the point of intersection where these two is because these two is intersected here. That is where the C to C2 is going to pass. This point, if you join C to C2, is going to pass through. I want you to do that. You're going to see that it is going to pass through that point. That is your center of enlargement, which is X is -2, Y is -2. So this is your center of enlargement. So you've got -2, -2. Okay, so the center of enlargement, we say the center is -2, -2. Okay, then scale factor. Remember, guys, I told you to find the scale factor just to measure the image line over the object line. When I'm saying the image line, I'm saying the corresponding line to the image, which is B2, C2 over BC. A2, B2 like this. Let me be writing it down like this. You measure B2, C2 over BC. You measure A2, C2 over AC. You measure A2, B2. So this one can be A2, B2 over AB. That's how you find your scale. But already, guys, before we even talked about that is enlargement, we saw that it was increased by 2 by 2. This is your scale factor, the one that you increase, because it was 1, then it was increased by 2. So that's your scale factor. So in this case, our stretch factor, our scale factor is going to be 2. That is the idea there. So we're going to have +2. Okay, why is it +2 here? Because remember I told you, when the object and the image are on the same line, if the center is in between like this, then your object is on one side like this, the image is and the object they are on one side like that. The scale factor becomes a positive, but if they are from different sides, the scale factor becomes a negative. So this one was going to be +2. Okay, so I think this one was direct. It was actually direct. So this one was an enlargement. Then now we are going to check another one. Another question, which is item D. So on the D part, we are now given triangle ABC is rotated. Take note, this is a rotation of 90 degrees anti-clockwise about 0, 0 onto A3, B3, whatever that we have. Draw and label clearly A3, B3, C3. Then write down the matrix that represents this transformation. Okay, so take note, this is a rotation that we're talking about, 90 degrees anti-clockwise. As you know, guys, anti-clockwise is we're going to be 1, 0 here, -1 is 0, 0 minus 1, 0, 1. Okay, so this is your Y, this is your X. Remember, I told you the first point that moves is the one in the X. So if this point is going to be rotated 90 degrees anti-clockwise, so it is going to end up at 0, 1. Then we move on to this point in the Y-axis. If we rotate this one 90 degrees anti-clockwise, it is going to end up at -1, 0. So this is the matrix that you're going to use. Why? Because center 0, 0, you know that to find the image, matrix times object should give us the image. So already the matrix is there, which is 0, 1. Multiplied by -1, 0 like this, multiplied by the object. So the object now is that original triangle that you're given, which is ABC. So you just take the coordinates of what? A, B, C as they are. Okay, so remember our A there was 2, 1. So this is A, B, C. Our A was 2, 1. Our B was 4, 1. Our C was 4, 4. So this is what you're going to have. So row by column, guys, as you know, row by column is that. Okay, so this one, 0 times 2, that's a 0 here. Minus 1 times 1, that's minus 1. 0 times 4, which is 0. Minus 1 times 1, which is minus 1. 0 times 4, which is 0. Minus 1 times 4, which is minus 4. We move on to this row, which is of 1, 0 here. So this is one that you're going to use now at 1, 0. So you do the same, guys. We multiply to the first column, second column, third column. So that is the idea there. So 1 times 2, that is 2 plus 0. 1 times 4, that is 4 plus 0. 1 times 4, which is 4 plus 0 here. Okay, so this is what you're going to have at the end. We can combine these values. 0 minus 1, that's minus 1. 2 plus 0, that's 2. 0 minus 1 is minus 1. 4 plus 0, that's 4. 0 minus 4, that's minus 4. 4 plus 0, that's 4. So this is going to be your image now, which is now this will be triangle A3, B3. So it's going to be A3, which is minus 1, 2. So that's minus 1, 2. B3, which is minus 1, 4, in that order. And C3 in that order, which is minus 4, 4. So it's minus 4, 4. So these are the coordinates now that you're going to mark. So this is C3, A3, B3, C3. Now you mark these coordinates, you have got your triangle. Okay, so just like that, guys, we need to mark these points. Okay, so I'm just going to adjust here. Remember, your first point A was minus 1, 2. So minus 1, 2, that will be somewhere here. Minus 1 is in between. I'm just going to increase this. Minus 1, this is minus 2, so minus 1 is here. So minus 1, 2, mark your point. This was A3. B3 was minus 1, 4. So minus 1 versus 4 here. That's your B3. You mark your point. And remember, your C3 was minus 4, 4. So it's minus 4, 4 here. You mark your point. This is your C3. Okay, so just like that, we can be able to join our points to have the image. Just like that, guys. As you can see, it's actually easier. If you understand the concept, guys, it makes all these things easier. So using matrix method, it makes even your working to be neat because you do not have a lot of drawings on your diagram. So you need to know these matrices, memorize all the matrices that are used in transformation. Therefore, it's going to be much easier for us in exam if we know these matrices. All right, so just like this, we can join our triangle. We are done. So that is our triangle A3, B3. As you can see, truly they are isometries, guys. As you can see, truly these are isometries, okay, which means they are congruent. So truly it means it's a rotation. So that's what we're going to have in this case. Okay, so let's cross check the other part now. It was to calculate the matrix, write down the matrix that represents this transformation. This is your item 2. Already the matrix, you've written it here. So on item 2, you're just writing your matrix 0, 1, minus 1, 0. So whether you used this matrix to calculate from another item, this one does not matter. This is item 2. Answer the question that you're given. Write down the matrix. Write down that matrix. Are you getting the sense? So that is the idea there. So that is that was our question, guys, on number 8, transformation. So as you can see, it was pretty easier. Yeah, as you can be able to work with much questions from your past exam papers, you can see that these things, they're actually clear. Everything is actually clear there. Okay, so that's what we're given, guys, on this part. Yeah, just have to work on much questions as possible, as much questions as we can. But as you can see, it's pretty easy. 12 marks for that. Okay, number 9, we are given. The table below shows grades which were obtained by candidates in a mathematics examination. So this was a mathematics examination that we see. Calculate the number of candidates who wrote the examination. So there we are not wasting much time. Calculate the number of candidates, you simply have to add. So this is 10 plus 25 plus 40 plus 24 plus 21 plus 30. You add all these elements that we are given, and it's going to give us something like 150. So 2 marks, you add like this, then you write your, and do not just write 150 using a calculator. No, It's not about calculator. Write down the working, then the answer. Okay, number B, the B part, state the model grade. Remember, the model grade is the one with the highest frequency. So the highest frequency is 40, which means the grade is C. So the model grade is C. The B part, the C part is now using a scale of 2 centimeters to represent 5 candidates. Draw a bar chart. So this is a bar chart that you're drawing. So a bar chart is familiar to a histogram, but they are not the same. It's just, it possesses some features of a histogram, but this one, the bars, they will be separated like this. These bars, they'll be separated and they'll be having same thickness throughout. And this one is your frequency. This axis is for the frequency. Unlike on a histogram, remember on a histogram, we have got frequency density versus the classes, and that one is for grouped information, and this one is for ungrouped information. Okay, so that's what we have. So it's a histogram, guys. Just straight A here corresponds with 10, B with, so that is what you need. So this is the most important part. This frequency axis has to be to scale. 2 centimeters represents 5 candidates. So it's going to be like this. I've got my scale here. 2 centimeters representing 5 candidates, which is on the frequency here. So that's what I'm going to have. Okay. So like I said, you're going to maintain the number of boxes. Like it is supposed to have same thickness and separated evenly throughout. You separate these bars evenly. Okay. So the first one, it was A, grade A, and our grade A corresponds with 10. So this is what you're going to do. Grade A corresponds with 10. So you're going to just mark here. Like this. Let me just reduce my ruler a little bit. Like, okay, so this one, this is your grade A. You're going to just have a certain distance. Like here, I'm just going to leave half of a box. Remember, this is one box of it, the full box. So I'm going to take from the half of it, half of this box is the one that I'm going to indicate to represent my boxes. So I represent up to 10 here. That's where I'm going to have my box up to 10 like that. Okay, so you have to maintain same distance throughout. So the gap that you use on the first bar, this one, like as you can see here, I have left a distance on the first bar of a half box. So I'm going to maintain half box throughout. And also here, I'm just going to join using freehand, guys, but you're supposed to use a ruler, but for me, guys, to rotate and this and that, but supposed to use a ruler there. Then you can write A inside the bar, or you can write aside of the bar. You can write your A here, or you can write your A inside the bar. That one does not even matter at all. Okay, so that is what you're going to have in this case. So here, I'm just going to write my A just below the bar like this one. Okay. Then you move on to the other bar. So what I'm trying to say is that, as you can see here, we left half a box, which is 1 unit. Half of a box is 1 centimeter, actually 1 centimeter. We are going to maintain also from this box to this one. We are going to leave one box, we draw another bar. That's what you do on a bar chart. Okay, so let us get back to our question, guys. As we saw, that one, B corresponds with 25. So it's B versus 25, which means our bar is going to be directed 25. We leave a box like what I said, you draw your bar up to 25, and the same thickness. This box is half or 1 unit, like this one is 1 centimeter. So it must be also the same throughout. These boxes, they must be same thickness, separated the same throughout. So they are separated the same, they've got same thickness also. Okay, so like this. We can draw our bar here. So this is going to be our bar. Okay, we move on to this one. We can draw our bar. Yes, you can do all those stylish things of shading, this and that. That one, guys, you'll be having a lot of time in exam. If you've got time to shade these graphs, you'll be having a lot of time. Okay, you join there using a ruler also. So it corresponds to 25. So this is your B. Okay, so that's where you're going to have your B under that graph or inside the graph, does not matter. Okay, then we move on to C. C was 40. So we are going to see 40, just like what we did, guys. As you can see, it's a repetition. So C to 40, you maintain the same box here. One box from this one is going to be here to here, and 40. Oh, we have to increase, we have to reduce this, guys, up to 40. That's somewhere here. This is my 40 here. So I'm going to join up to that point of 40 there. Okay. So that's the idea. We join our points. Let's just hope it is not going to affect us. Okay, so that's our 40 somewhere here. All right, we move on to this one. We do the same. We join up to 40 again. Okay, guys. Okay, something like this. Okay, so up to 40, just like that. So this is how our bars are going to be. Just like this, guys. You join also properly there. Okay, so this is grade C. You mark your grade, yes, grade C. You move on to grade D. Remember, grade D, that was 24. Let's cross check, guys. Okay, that was 24. Okay, so you move on to grade D, which is 24. So you maintain again, half box again. So here you can just do it like this. So we want to know exactly where our 24 is located at. So remember, according to scale, this is 2 centimeters to represent 5. So it means 2 boxes represent 1. Whenever we see 2 boxes, is 1, 2, 3, 4, 5. That is what it means. So which means 24 is just 2 boxes below 25, because these are 25. So 2 boxes here, it will be 24. 24. So this is where we are going to join. Back to where? To the ground. So that's how your bar chart looks like. Just like that, guys. As you can see, it's pretty much easier. Pretty much easier. Just do as much questions to revise, guys. We do not have a lot of time left. We just have to revise. So here, guys, like I said, you use a ruler, but here it's going to take me a lot of time to shift this ruler. They said that, okay, but that's what it's going to look like. This is our grade D. Then we move on to the last grade, which is E, and E was 30, if I'm not mistaken. That was 30. Okay, let's just cross-check on our, okay. So we have got E, which is 21, then U. Okay, so guys, we've got E, 21, then U, which is that. Okay, so E is 21. So 21 means it's just 20 here. Then to have 21 is going to be 2 boxes from 20. So this is 20, 21 here. So that's our 21 there. Okay, so you join back to the ground like that. So maintaining same thickness of the bars and also separating these bars with the same distance. You separate them with the same distance throughout. That's how you do. Okay, so you just have to separate these bars with the same thickness, and they will be separated evenly. So that's how your bar chart is going to look like. You join them properly, guys. Then we say this is our grade E. So this is our E. Then the last grade is grade U, which was 30. So the grade U is the one which was 30. So you must draw something which reaches 30 here. Okay, so there lies our 30 somewhere here. That's our 30 here. All right, so I'm just going to join up to that point of 30. Okay, somewhere here. Okay, so this is what you're going to have here, up to 30. We join up to 30 like this. Okay, we move on to this one. It's going to be 30 here again. All right, that's somewhere here, becomes your 30 like this. Okay, so you can actually join here, guys. That's our 30 direct, just a little bit here. It was a little bit. I'm just going to erase this part here. All right, somewhere like this. Okay, so that is our bar chart. That is what our bar chart was going to look like, guys. This is what it was going to actually look like. Okay, so we just hope, guys, everything is actually clear there. All right, where is my bar chart now, guys? I can't see my bar chart here. All right, so, but I just hope, guys, we saw what happened there. Okay, I wonder what's happening now with my bar chart. It disappeared. It disappeared. Or what happened? Okay, but I just hope we saw what was happening there. Maybe it's gonna save some time. You know, these applications, guys, it has to save this and that. But I'm trying to even redo this thing to back to where it was. But that is what it was going to actually look like. As you can see, guys, it's gonna save for some time, but I think it was actually pretty fine. Okay, so that was our bar chart. Then On the D part, we are now given here, this is our D, given that the passing grades is A, B, C. Find the probability that 2 candidates chosen at random passed the examination. Okay, we are now on probability. Okay, so guys, take note here. Just to pass an examination, we are being told it's what? You must have these grades A, B, C. So we're going to count those who obtained A, B, and C, okay? So first of all, you have to add these ones from A to B to C. So how many do we have? It's going to be 10 plus 25 plus 40. All right, so plus 40 like this. That is 75, okay? So we have got 75 of them in A, B, and C. So remember that probability is the required outcome over the possible outcome. So you're going to have 75 over the total number of students. We said there are 150. So this is to pick the first student. For us to pick the second one, that is 74. There were 75, so it's going to be 74. We have removed one student, so they are now 74. Out of the total also is going to be affected, so it will be out of 149. Remember, we removed one of the students there. All right, so this one, guys, even with the calculator, you can just simplify straight there. 75 over 150, whatever that we get here, we multiply to 74 over 149, which is going to give us 37 over 149. So this is 37 over 149. So just like that, we are done. The E part, we are now given if does not mean drawn, or if it means, it's like we are assuming, it's an assumption that, let's say we are to have a pie chart. So they are saying if a pie chart is drawn, for this information, calculate the angle of the sector that represents grade C. So you are not drawing a pie chart, you are just calculating the angle. Answer the question, guys. Okay, so remember, how do you find theta, which is the angle of a sector? We know that theta is the frequency over the total frequency times 360 degrees. That's how you calculate the angle of a sector. So grade C is the frequency that you're talking about, the total frequency, the number of candidates who are there. So what is the frequency for grade C? How many grade C do we have? There are 40 of them. So it's going to be 40 representing grade C. So it's 40 over the total frequency, which we said is 150. So it's 150 total candidates times 360 degrees. That one is going to give us the angle of the sector. So 40 over 150 here. Okay, so this is 40 over 150. Whatever that we get, we multiply to 360 degrees, and that's 96 degrees, just like that. Okay, so that was the angle of the sector, the angle which represents grade C, because here we are talking about grade C. So that was the idea there. Okay, so guys, as you can see, it's pretty clear and easier at the other end. So it's a matter of working with different questions and examples. It can actually help. Okay, so let us quickly move on to the question 10, where we are given now the question 10 is the length L of, we are given the length L of a rectangle of constant area varies inversely as B, the width. Okay, so it varies inversely. Okay, so take note, guys, here what you're given. State the relationship between LB and a constant K. Okay, so this is what you're going to do. Let us put it here. So we are given that the length that you are given of a rectangle, this is our item 1 here, it varies inversely. So we are given that of a rectangle constant, it varies inversely as B. So that is 1 over B, like this. Okay, so that means our L is going to be K over B. So this K is actually the area. If you have to cross check, that is what it means. Okay, so anyways, this was the question to write L in terms of B and a constant K. Okay, remember, when you introduce the equal sign, that's where you introduce what? The constant. Okay, so item 2, we are given the value of L, the value of B, then find B if L is 10,2. So from this information that you are first given here, you must find the value of K from this from the complete information that you're given. You use that one to find the value of K. So what are you given from the first item?
we are given that on that condition, our L is 8,5. So L here is 8,5. So this is 8, item 2. So 8,5 is equal to K over B. Our B is 6 at that moment. Okay, so that means using this information, I can be able to calculate the value of K. Just need to cross multiply here. That's 1 times K. It's K is equal to 8,5 times 6. This is 6. I'm writing as B, but it's 6 there. Remember, that was a 6. Okay, our B was 6. So it's 8,5 times 6. So 8,5 by 6, which was going to give us 51. So that means we are going to obtain 51 here. That is the value of K. So it means L is equal to, from this equation now, K, we have found this K is 51 over B. So it's going to be over B. So the question was for us to calculate the value of B. Find B when L is 10,2. You are given that L is 10,2. So in place of L, you are going to substitute 10,2. That is what the question is actually saying here. So in place of L, we are going to substitute 10,2. So 10,2 is equal to 51 over B. So how do I find B? I can simply cross multiply here. That to be 10,2 times B. That's 10,2 B is equal to 51. So to find B, divide by 10,2 both sides, divide by 10,2 both sides. So our B is going to be what? So if we divide 51, divide by 10,2 here, is going to give us 5. So our B is going to be 5 centimeters. Okay, remember the units were in centimeters. So this B is going to be in centimeters, just like that. Okay, so guys, it was pretty easier for this question. Let us cross check the other part now. Answer the whole of this part on a sheet of graph paper. So everything has to be done on a sheet of graph paper, guys. Represent the following inequalities using a, take note about the scale here. It's 1 centimeter to represent 1 unit. Remember, as we know that the complete box, this one is 2 centimeters. So now they are saying 1 centimeter is a half of box. So it's 1, 2, 3. So it means 2 centimeters actually represents 2 units both. So that is what they mean in this case. Okay, so I'm going to have my scale like it was supposed to be like this. 1, 2, 3, 4, 5, 6, 7, 8, like that. Each and every 1 centimeter is 1, is 2. So that is what they were trying to say. Okay, and anyways, you can do that, it's fine, but you can, it's 2, 4. Okay, so this is for the x-axis. And 2 centimeters to represent 1 unit on the y-axis. So on the y-axis, as you can see, is 2 centimeters representing 1 unit that we are given. Okay, so I think that one is clear. Draw the x and y-axis for x, which is greater than or equal to 14. Okay, this is what we have, guys. This thing is actually taking some time to respond. Okay, so this is x greater or equal to from 0 to 14, y from -3 to 5. So you just need your scale properly. Item 1, show by shading the unwanted region, the region in which these inequalities are going to be actually defined at. Okay, so we are going to first start with this one. X is greater than or equal to 3, guys. This ones I talked about it. Just draw your line. X is equal to 3, and you can shade by looking at the line. Okay, X is equal to 3. This is where X is equal to 3 here. So you can just draw. This one is a continuous line because it was X is greater than or equal to. So it's a continuous line. So you're going to draw not a bold line, just a continuous, guys. Continuous doesn't mean bold. No, bold is you're now rewriting on that line so that it becomes bold. No, it's not about that. It has to be a continuous line, simple. That is what that is what it simply means. Okay, so I think you understand what I'm trying to say, guys. Okay, so I'm not going to draw a much bigger line. Okay, just this one is fine for now. So you write your equation, x is equal to 3, then you can shade. So I'm just going to write x is equal to 3 here. X is equal to 3 here. Okay, so remember that the equation here was, the inequality was that x is greater than or equal to 3. So which values that we have are greater than 3 from this line? So these are the values on the right side. So we do not need the left side of this line. This one is actually wrong because they are less than 3. So you shade these values, they're actually out. We do not need them. Okay, so that's it. We're done. We move on to the other one. It was y is greater than or equal to -2. y is greater than or equal to minus 2. We draw the line of y is equal to minus 2, a continuous line because there's an equal to there. So y is equal to minus 2, where do we find it? This is our y is equal to minus 2 here. We draw the line there, and it has to be a continuous line. Okay. Okay, so y is equal to minus 2 here. All right, so let's just draw our line here. We're going to have our line at this point. Y is equal to minus 2. All right, so I've drawn the line of y is equal to minus 2. I just write the equation. Y is equivalent to minus 2. Take note, it was greater than or equal to. So as you can see, these are the bigger values on top. From minus 1, 0, 1, 2, these are bigger values. So the lesser ones are the ones which are on this side. So you shed the unwanted region, which is the lesser region. Minus 3 is less than minus 2. Minus 5 is less than minus 2. So you shed that region. So that's what it means. Okay, move on to the last one. Remember, it was x plus 2y. X plus 2y is less than or equal to 8. So this one, we can simply use double intercept to draw this line of x plus 2y is equal to 8. It's going to be a continuous line, but you can just use double intercept. Remember, guys, what I told you for double intercept, you just need 2 points, x and y, or you can use table values. It's not a big deal. So using double intercept is easier because you are saying when x is equal to 0, what is the value of y? When y is equal to 0, what is the value of x? That is the condition. So when x is equal to 0 here, what is the value of y? It means here there's a 0 here. So you're going to be left with the 2y is equal to 8. We divide by 2 by 2. So y is equal to 4. So it's going to be 4. You move on. When y is equal to 0, y is equal to, I mean, there's nothing. So x will be equal to 8. So these are the 2 points that you mark 0, 4 and 8, 0. Okay, so they're enough to draw this line 0, 4. 0, 4 is somewhere here. When x is equal to 0, y is 4. So you mark direct at 4. Then 8, 0, when x is equal to 8. Okay, let me adjust here. So this is our 8 here. Okay, so now we can join these 2 points from 4 to 8. So let us make our ruler to be a little bit bigger. Okay, it must be a little bit bigger here. Okay, so this is minus 4 and minus 8 there. Okay, so what you simply do with these points being marked together, you join. Remember, that one was a continuous line because it was less than or equal to. So that's what you simply have. You can join your points. Okay, now let us cross check which side are we going to shade. Remember, we are told that our x, our inequality is less than or equal to. So less than, this is, remember I told you for a line like this, this is the lesser side, this is the bigger side. So we need this side. This is the one that we need. So we do not want this. We are going to shed the part that we do not want. So we do not want this side. We do not need this side. We shed this side. Okay. Just like that. So we are going to be left with this region. And remember, the equation of the line has to be written x plus 2y is equal to 8. You write the equation, not the inequality. Okay. So like we can see, guys, that was our inequality. It was going to be like this. Our diagram was going to look a little bit of this nature with this region left out and shaded like that. And we can actually answer any of the questions from this region that we see here. Okay, so let us see the first question that we are given after this. Find the region. Okay, from the region, sorry, we are given that from the region here, find the coordinates of a point that gives a maximum value of 3x minus 2y. Okay, guys, this one I told you, this is a trial and error question, where you need to try your question, your points, and you do not just try your points randomly like you do not know what is happening. No, you work with the points which are at the boundaries. What am I trying to say? The points that are at the boundaries are the ones that are surrounding our diagram. We're talking about this point here at 3. This one, it will be 3, whatever that you have here at this point. This one at 3 minus 2. We have got this one at 12 minus 2, this one. So these are the 3 points actually that we're going to try into this question. Okay, so we said we've got, let me write them. We said 3, and this one will be what, 2,5. So it's 3 versus 2,5. So I'm just going to list the point, because for you to have the maximum, you can't have the maximum value without the points. Okay, so we said these are the points that we're going to expect: 3 and 2,5. So 2,5 is not going to work, so we can take 3 and 2. We saw again it was 3 and minus 2. Is that so? Okay, let us get back here. 3 minus 2. Okay, so that one is 3 minus 2 and 12 minus 2. Okay, so those are the 2 points that we have. So we've got 3 minus 2, 12 minus 2. These are the points that you can try. Do not try any points that are inside. You try the points which are at the boundaries. So the boundaries, these are the boundaries here. At the boundary here, these are the points that you try. Anything inside this region, never try to pick those points. It's a waste of time. You won't find any answer there. Okay, so from these points, which one is going to give us the maximum value? So what are you simply doing? You are simply substituting. This is your x, this is your y. This is your x, this is your y. This is your x, this is your y. So when you substitute 12 in place of x, are you getting the maximum value there? Okay, let's take this one. Guys, it's a waste of time to try these 2 points. I'm just going to work with this one, the 12 minus 2. Okay, yes, we can try 3, this and that, but this one is the one that was going to give us answer here. 12 minus 2, because if I substitute on 3x, so it's 3 times x, which is 12, minus 2 times y. As you can see, our y is negative 2, so negative and negative, it gives us a positive, so it will be 36 plus 4, which is 40. So as you can see, yeah, because if we try this one, it's going to be 3. 3 is actually less than 12, so there's nothing that we can get. So the point 12 minus 2 is the one that gives us the maximum value. So you can't write the answer without knowing, you can't write this point without knowing the answer for the maximum value. Okay, so the point here was 12 minus 2. And what is that maximum value now? State the maximum value. This is the one that we got here, which is 40. So our maximum value was 40 because we already calculated it. So we're just writing the answer there. Okay, so that was how the question was supposed to be done, guys. As you can see, it was pretty clear. And all you need is to work on match questions. Like I'm saying, guys, revision, revision, revision. Please do your revision as much as you can. On the table there, we are given the pattern below refers to a number of elements in the set and the number of subsets X. Study the pattern, guys. Everything that you are told to study, they mean it. Study that pattern. It's not a direct thing. And this type of questions, guys, it's something that you have to study from the question that you are given. Okay, so here I just studied this and saw that these numbers, they are actually being obtained by raising to the power of 2. 2 to the power of 1 is 2. So this is actually 2 to the power of 1. 2 to the power of 2 is 4. 2 to the power of 3, 2 to the power of 4. So which means this P is 2 to the power of what? 2 to the power of 5. So that means our P, because we asked to find the value of P. So P is 2 to the power of 5, which is 32. Okay, so that was our P there. Then let us move on to Q. If we are to cross-check Q here, we need this one. We are given the answer. So let us get back, guys. If we said from this number, we are raising to the power 2 to the power of this, because this number that we get here, like what we did, we said 2 to the power of 5, we got 32. So it means this P, this Q that we see, it's a power. So it's 2 to the power of Q, which gave us 128. That is what happened there. So if 2 to the power of Q gives us 128, we are now back to your normal equations. How do you solve such type of an equation? Which type of an equation is this? These are initial equations. Remember, I talked about initial equations where you are supposed to make sure that the bases are the same. So this is 2 to the power of Q. What about 128 in base of 2? Is 2 to the power what, which gives us 128. So this is to the power of 7. So you can try, guys. This is paper 2. You can try 2 to the power 2, you get 4. You move on 2 to the power of 3 until you get 128. So you're going to get 128 at 2 to the power of what? At 2 to the power of 7, like this. 2 to the power of 7 is the one that is going to give us 128. So it's to the power of 7. So remember that if the bases are the same, it means the powers are the same. So Q is equal to 7. So that is how you got this. Q is 7, just like that. All right, then let us see the other part of the question is now express R in terms of N. So this is what is happening. We have got our R here in terms of n. So remember, guys, what was the relationship? We were saying to find this number that we have, it's 2 to the power of this number. So which means just like what we did. So it means our R here, in order for us to have R, is going to be 2 to the power of whatever number that n is representing. So R is equal to 2 to the power of n. That is what is happening there. Okay, so I think it was going to be an easier way using this concept, and we can move on to the other part of the question. This one again, you have to study of what is happening, guys. I hope you guys from your accounting there, your accounts exactly give us something. Okay, what the debit does. Okay, Mr. Mbudzi here invested, Mbudzi Investments, it borrowed 6,000 from a bank to start a project. The bank charged them interest and expected the company to pay 120 per month to service the loan. The following is an incomplete loan account statement for Mbudzi Investments. Okay, so let us see what these guys were actually having. It's a debit. A debit you add, isn't it? Yeah, you add. A debit, credit you subtract from your accounts concept, guys. So this 80, we add to this one, we get this, we subtract this, we get this, we add, subtract. Okay, so I want you to see something from your debit here. If we are to find the difference of the first debit here, it's 80 minus 79,47, which is something like 0,53. So here there's a difference of 0,53 here. All right, there's a difference of 0,53. Here there's no difference because we are crediting 120 every month. And we move on from 79,47 to 78,93. Let us see the difference. 79,47 minus 78,43, 78,93, sorry, 93. We have got a difference of 0,54. Okay, so here there's a difference of 0,54. By just looking at this term, guys, we can see that here there will be a difference of 0,53, 0,54. So here there's going to be a difference of 0,55 like this. But what was happening? It was 80 minus this difference, we get this answer. This answer minus this difference of 0,54, we get this one of the 78,93. So it means 78,93 minus 0,55, we must get this W here. So this W is going to be 78,93 minus 0,55. So that was the case there. So 78,93 minus 0,55. And it's going to give us something like 78,38. So this W here that we see is 78,38 like that. Okay. I hope we are together there. Okay, then this is what was happening. We know that Y does not change, guys. Okay, we must find X first. Okay, X. So how do you find X from W? Remember, a debit you add. So you're going to add this W here to this previous amount that we have here. We are going to add W to get X. So X is going to be that amount of 5,878,40 plus W, which is 78,38. You add a debit. Okay, so you're going to add there. So if we add, it's going to be what? Okay, let's just add, guys. We've got these values, isn't it? 78,38 plus this number 58,78,40, which is just 4. So you're going to obtain 5956, 78. That was 78. It's not, is that so? So these are dollars actually. So these are dollars. As you can see, dollars. Okay. So which means your W, whatever that you're going to have is dollars. Your X is dollars. So here your X is going to be 5956,78. Okay, that's our X. Then Y is a credit. As you can see, you're crediting 120, 120, 120. So your Y is 120. Okay. If you credit 120, you subtract whatever that you credit. So to find Z is going to be this amount minus 120. Okay. So our Z here, we can just put it here. So our Z is going to be this amount of 5956,78 minus 120. So this amount that we have as it is minus 120, the one that we have credited is going to be 5836.78. Okay, something like that. We said 5836.78 dollars. So that's our Z. Okay, so that is how you could have found the values of X, Y, and Z. Okay, so let us see what was the question about here. Okay. The question, calculate the values of A, W, X, Y, Z. So we have got these values. I think it was pretty easier. All right, number 12, which is our last question of the paper. We are now given a velocity time graph. This is a velocity time graph. Why? Because we are given that the velocity of a particle moving along a straight line is given by, this is the velocity that you are given, an expression for velocity. So the table now below shows the corresponding values of V and T. So these are the values, as you can see, just like a quadratic graph, it was supposed to be y is equal to 15 plus 7x minus 2x squared. This is a quadratic, the same way that you do, guys, when you are drawing a quadratic graph is the same way that you use here to draw a velocity time graph, or it can be a distance time graph. A distance time graph. Okay, so I'm going to make a video actually on distance because I didn't do that one. I just did on velocity time graph. Okay, so with time, guys, I'm going to work that one. Okay, so let us quickly check our question. What was the question on item A? The A part, we are now asked to find, okay, what happened with my marker? Let me just put back my marker here. Okay, it's back. A, find the value of P and the value of Q. So the value of Q, the value of P, whatever that we have, is simply substituting where we are given our equation here. Okay, so in place of T, we're just going to substitute. Even with, guys, this is 2 marks, which means each one is 1 mark. So on your calculator, you can substitute like this, 15 plus 7T. So it's going to be plus 7, open bracket, and put the T, which is 1. So your T is 1, so it's 7 times 1. Minus 2t squared, 2 times 1 squared. You put that one, you get your answer, which is 20. So P here is 20. Your Q, you do the same. When this one is 4, you do the same. And okay, let's just do this one. Let's just do it. It's now 4, so I'm just going to substitute here 4 here. Okay, I'm just going to put 4. Move on to this one. I'm going to put 4 again. So this will be 11. Okay, so our Q is going to be 11. So with this information now, the question is going to be using a scale of 2 centimeters to represent 5 meters per second on the v-axis, which is the velocity axis. Remember, it's a velocity time graph where this is velocity in meters per second versus time in seconds. So that is what you have. So the velocity they are saying you're going to use 2 centimeters, 25, so it's 5, 10, 15, 20, and so forth. Then 2 centimeters to represent 1 second. A second is a time. So on the time axis is 1, 2, 3, 4. That is what it means. Okay. Then you're going to draw from t is equal to 0 to t is equal to 6. Just like what I did on this part here, as you can see, that's what you're going to have here. This is your velocity and your time. So from there, guys, you can simply mark the points that you're given because you need to draw this graph. So it's simply issue of what? Marking the points that you're given. So let us quickly mark our points. The first one is 0, 15. Okay, so that's 0, 15. We need to reduce here. So this is when x is equal to 0, y is 15. So it's direct. This one, 0, 15. You mark your point. The other one was 120. Remember that one that we calculated. So it's 120. The other one was 221. Okay, so let us count. We talked about this scale before. It means 2 boxes bend 1. So this is 1, 2, 3, 4, 5. So 2 boxes represents 1. So 21 is just 2 boxes from 21, 2. So this was 21. So it's 2 versus 21. The other one was 3 versus 18. 3 versus 18. This is 15. 16, 17, 18, just which means count 2 boxes, 2 boxes, 2 boxes. So from 15, how many boxes? There are going to be 6 boxes from 15. That is your 18. Then that one was 4 versus 11. So this is 10 here. Then 11, just 1 box, 2 boxes from 10. That would be your 11. Then it's 5 and 0. 5, 0 here. The other one was 6 and minus 15. Let me cross check if I'm not mistaken, but that was 6 and minus 15. Okay, 6 and negative 15. All right. So mark the point just like what we had on the other points, and actually it's gonna work properly. Okay, so this is let me reduce this side. Okay, so it's 6 versus minus 15. Is that so? Yeah, 6 and minus 15. So that's somewhere here, 6 and negative 15, somewhere there. Okay, so these are the points that you're going to join now, just like a quadratic graph, guys. Make sure that you join it in a smoother way and not gross. So here, guys, because of the pen that I'm using, this and that, it's not going to be smooth as it's supposed to be, but just draw a smooth graph here, joining your points. It must be smooth. All right, so here, guys, like I said, I can't be able to draw this smooth graph like the way it's supposed to be, but I'm trying my best. Okay, this one is not smooth. Let me remove this part. Okay, so I don't know, guys, you're just going to see how it's going to look like at the end. To 5 here. Then from 5 to the other point like that. Okay, so yours, guys, should be smooth than this, very, very smooth. And write down your equation of the velocity time graph. V is equivalent to, what was the equation? Let's get this equation that you're given here. You write it as it is on your graph. Okay, so on our graph, let us write our equation. It's 15 plus 70. So this is 15 plus 70 minus 2t squared. Just like that, you're done. Yes, just like that, guys, you're done. And from that graph that you have drawn, the question now is use your graph, not someone's graph, but the one that you have drawn is the one that you're going to use. So these answers, they might not be exact because remember the smoothness, this and that. Okay, but we want to find the value, which is the maximum value of V. So the maximum value of V is, it occurs at the turning point of your graph, where the graph turns. What is the value of V there? Okay, so this is what it means. The maximum value of V, where this graph is having its turning point here. So you join using your ruler, guys, straight from this point. As you can see, this one was going to correspond to something like 21,5 because it was going to be somewhere here. So you join, guys, straight to the graph. Okay, so this was going to be, remember, two boxes, it says it's 21. So this is 21, this is 22. So in between 21 and 22 is 21,5. Okay, so that one was 21,5 meters per second. That was your velocity here. So V was 21,5 meters per second. So I'm just going to remove this. So it was meters. It is velocity measured in meters per second. Take note, meters per second, just like that. Okay. Then item 2. The acceleration now on item 2, the acceleration of the particle when t is equal to, guys, I explained on the velocity time graph that we did that the acceleration you calculate the same way that you do on the gradient. Acceleration you calculate the same way that you do on the gradient, which means when t is equal to 3, that is where you're going to draw a tangent, just like what you do on gradient. Okay, so t is equal to 3. Let us see. Our t is equal to 3 here, straight to the graph. It meets at this point. That is where our t is equal to 3 is located here. You draw a tangent there. Remember, a tangent is simply a line which touches the graph. It doesn't enter this inside the graph. It just touches the graph. So at point 3 here, it must just touch the graph like this. That's a tangent. So you can just draw, at least this tangent must be 3 centimeters. Okay, at least 3 centimeters. Do not make it big or too small. At least 3 centimeters. So that's your tangent. And what did I say? From the tangent that you have drawn, you are supposed to take points. Remember, you want to calculate gradient. So you take points. And the first point must be the point which he has got 3, where 3 is from. This is 3 versus 18. Remember, this is 18 here. So that's your first point that you're going to take. Okay, so this is item 2 of C. So the first point has to be 3. So this is 3 versus 18, like this. Okay. Then you pick any other point of your choice. So here I'm going to pick the one for 4, but it's 4 versus what? This is 10. 11 here. What was this point? 10, 11, 12. Yeah, it's supposed to be somewhere there, 13 if I'm not mistaken. So it was supposed to be 4, 13, somewhere like that. Okay, so this is the point that you're going to take. Then you take any this one, guys. This second point is of your choice. You're going to take, maybe someone was going to take 3,5, or I don't know which point were you going to take, but make sure that you've got 2 points, because remember, you want to calculate gradient, which is your acceleration. Okay, so the way that you calculate gradient, how do you calculate gradient? You name your points. This is x1, y1, this is x2, y2. And that acceleration is the one that is equal to gradient, which is y2 minus y1 over x2 minus x1. So just like your gradient, y2 is 13, so it's 13 minus 18 over x2, which is 4 minus 3. Okay, so 13 minus 18, that's minus 5 over 1, which is going to give us minus 5. But this is acceleration, so it's measured in meters per square second. So that will be your acceleration, just like the way you calculate gradient, but this one is acceleration. So guys, as you can see, pretty much easier. Let us cross check our last question now, which is the distance. Okay, item 3, that is the distance traveled by the particle from t is equal to 0 to t is equal to 5. Okay, so how do you find the distance which was traveled? Okay, this is what you simply do, guys. To find the distance, remember I told from t is equal to 0 to t is equal to 5, which means we're talking about distance, which is the area under the graph. This is your graph here, under this graph up to 5 here. So you have to calculate all these boxes that are there. You calculate all boxes, because you're talking about this region, guys. Remember what I told you, distance, you calculate the same way that you calculate area. So this is area under the graph. Okay, so you're going to calculate this box. I don't know here, you indicate like you're counting like this box, you know that is 100. So just write here 100, 100, 100, 100, all those 100. Okay, you calculate everything there. That's what you're going to do. Okay, so calculate all boxes. Calculate all boxes here. So you're going to calculate all these boxes from 0 up to 5 under the, I'm saying under the graph here. This is your graph. Under this graph, that is where you're going to calculate them. Okay, so that's what I'm trying to say. You calculate under the graph. So after calculating, how do then I find my distance, which is the area, which I said is the area. So distance is equal to area. So distance is equal to area. So therefore it is equal to what? Number of boxes that you have calculated there over 100. So it's going to be over 100 times area of the unit square. Okay, so remember guys, I told you about the unit square before. So number of boxes, in this case, I calculated mine according, you have to calculate, guys. I don't know what you're going to have. In fact, I didn't calculate, guys. I wanted to lie that I didn't calculate. So you're going to have your number of boxes here over 100 times the area of unit square. Okay, so let's get back to our graph and see what is the area of the unit square. The area of the unit square is this first box that you see here. This is the first box that we see. According to this first box here, it's 1 and here it's 5. So 5 times 1, that is the area of the unit square. So it's 5 times 1, which is 5. That is the one that you're going to multiply with here. So whatever that you're going to get, you multiply by what? You multiply by 5. So that will be your answer, guys. So here, calculate these boxes, divide by 100. Whatever that you get, it's distance, which is measured in meters. Your answer here is supposed to be in meters. So I don't know what you're going to get, but that answer has to be in meters. Okay, so as you can see, guys, it's pretty easier if you revise a lot of questions. It can make things much easier. So what I want you guys from now is to work questions. Give yourself a task, at least a day. You must do a full paper from now, according to the days that we have. At least a day, at least. Make sure that each day you revise a full paper, as we are revising towards our exam. That must be a consideration each and every day. Make sure that you revise a full paper. It's either it's paper 1, let it be a full paper, or it's paper 2, let it be a full paper, because at the end of the day, you are not going to write 1 to 5, you are going to write a full paper on your final exam. So that means you must train yourself now to answer full papers. So that's it, guys, from Maison African Motives, working on O-level maths till we meet again.